Hello there, and welcome to Just About Earth, a place where curiosity slows down, science stays gentle, and big questions are allowed to stretch out comfortably without needing immediate answers. Wherever you happen to be listening from tonight, whether the lights are dim, the room is quiet, or the world outside is still humming along, I'm glad you're here. This is a space for unhurried thinking, for letting ideas unfold at their own pace, and for giving the mind something steady to rest against while the body begins to relax. Before we go any further, take a moment to notice where you are. What time is it where you're listening right now? Is it late evening, early morning, or somewhere in between where the day hasn't quite decided what it's doing yet? Maybe you're listening from a familiar place, or maybe this is part of a routine you've only just begun. Either way, this moment belongs to you, and there's no need to rush it. Tonight's journey begins with a question that sounds simple at first, almost playful, but becomes more interesting the longer you sit with it. What if civilization has happened before? Not just once, but many times. Not as a myth or a fantasy, but as a quiet possibility written into the long, patient history of Earth itself. What if the world we recognize with cities, tools, stories and systems is not the first version of organized human life, but merely the latest one? If you find this kind of slow exploration soothing, or if these ideas help your thoughts unwind rather than race ahead, you're welcome to like the video or subscribe. It helps this calm corner of science reach others who might need a gentle pause as well. But for now, there's nothing you need to do. Just listen, breathe, and let the ideas settle where they will. We tend to think of civilization as a straight line, a beginning, a climb, a present moment, and then a future stretching forward. In school books and documentaries, the story usually starts a few thousand years ago, with farming, permanent settlements, writing, and tools made of metal. Before that, we're told, humans lived simply. They hunted, gathered, moved with the seasons, and left behind only scattered traces. Civilization in this view is a recent invention, fragile but unique, and unmistakably ours. That story feels neat, comforting even. It gives us a clear place in history. We are the builders, the first to shape the planet this way, the first to leave lasting marks visible from space, the first to unlock complex technology, organize societies, and record our thoughts for future generations. It places us at the top of a long ladder, with everything before us serving as preparation. But Earth has a way of complicating neat stories. Our planet is old. Not metaphorically old, but deeply, unimaginably old. It has been forming mountains, erasing coastlines, opening oceans, and closing them again for billions of years. Continents drift. Ice sheets advance and retreat. Forests turn to deserts. Deserts flood. And shorelines migrate hundreds of kilometers without asking permission from anything living on the surface. Against that kind of timescale, our written history is a brief flicker. Recorded human history spans, generously, about 5,000 years. Even the earliest known tools made by humans stretch back a few million years, which sounds impressive until you place them next to Earth's age. In that context, even the entire story of our species occupies a thin layer near the surface of time. So here's the uncomfortable thought. If civilization requires only a few thousand years to rise, and Earth has experienced stable periods lasting hundreds of thousands of years between major disruptions, then the math starts to feel a little less reassuring. There has been time, more than enough time, and time on this planet rarely stays still. One of the reasons we assume civilization has happened only once is because we expect evidence to be obvious. We imagine ruins, metal tools, large structures, and clear signs of industry. If something like us had existed before, surely we would have found it by now. Surely there would be unmistakable proof, impossible to miss. But that assumption quietly relies on another belief, the belief that evidence lasts. In reality, most things don't. Wood rots, textiles decay, food vanishes, Even stone structures crumble, are buried, dissolved, subducted or repurposed. Metal rusts, fractures, and eventually disperses back into the environment. Given enough time, almost everything returns to simpler forms. Geology is especially thorough. Rivers grind landscapes into sediment. Tectonic plates recycle crust back into the mantle. Glaciers scrape entire regions clean, leaving behind smooth rock where complex surfaces once existed. Oceans rise and swallow coastlines, then retreat again, taking harbours and settlements with them. If a civilization had existed tens of thousands of years ago, or hundreds of thousands, its remains would not look like abandoned cities with standing walls and legible signs. They would look like anomalies. Slightly unusual chemical signatures, odd distributions of materials, subtle patterns that don't immediately announce themselves as intentional. And unless we know exactly what we're looking for, those patterns are easy to overlook. There's also a quieter assumption we rarely examine, that any earlier civilization would look like ours, that it would build the same way, use the same materials, leave the same kind of footprint. But technology does not have a single path. It responds to environment, available resources, and cultural choices. A society that values durability might leave behind more stone. One that values efficiency might leave almost nothing that fossilizes well. Even today, much of our modern world would vanish surprisingly fast without maintenance. Glass shatters, concrete cracks and erodes, steel corrodes, electronics degrade into unrecognizable fragments. Given a few tens of thousands of years, most of our structures would be reduced to rubble. Given a few 100,000, even the rubble would blend into the surrounding geology. This raises a gentle but unsettling question. Are we confusing absence of evidence with evidence of absence? Human history as we tell it is built on what survived. Bone, stone, fired clay, and a few lucky organic materials preserved under rare conditions. But survival is not the same as importance. Entire cultures could rise, flourish, and vanish without leaving behind anything that fits neatly into our archaeological expectations. Consider how much of human knowledge today exists only digitally. If electricity vanished, or storage media degraded, vast portions of our culture would simply disappear. No inscriptions, no carvings, no durable records. Future investigators might find plastic fragments and strange alloys, but the stories, languages, and systems behind them would be gone. Now imagine a society that reached complexity without relying heavily on stone monuments or long-lasting materials. A society that lived in balance with its environment, rebuilt often, and left a little waste. From a geological perspective, such a civilization could be almost invisible after enough time passed. Earth has also not been kind to continuity. Over the last several 100,000 years, the planet has moved through repeated cycles of ice ages and warm periods. Massive ice sheets have covered much of the northern continents, kilometers thick in places. As they advanced, they crushed landscapes, ground rock into powder, and erased surface features down to the bedrock. When the ice retreated, it left behind fresh terrain, new rivers, new soils, a reset landscape. Anything that had existed before in those regions would have been pulverized or buried beyond recognition. Sea levels, too, have risen and fallen dramatically. During the last ice age, sea levels were more than 100 meters lower than today. Vast coastal plains existed where shallow seas now lie. These areas would have been ideal for settlement. Flat, resource-rich, stable. And now they are underwater, explored only in fragments. If earlier civilizations favoured coastlines, as humans tend to do, much of their history may be submerged. What we call prehistory is not empty. It's simply quiet. There are gaps in the human story that are wider than we often admit. Periods where little seems to change, then moments where technology and behaviour appear to accelerate suddenly. Transitions that feel abrupt, not gradual. Tools that appear more refined than expected for their age. Knowledge that seems to arrive already mature. These don't prove anything on their own. but they invite curiosity. It's also worth noticing how fragile civilization itself is. It depends on stable climate, predictable seasons, and cooperative social structures. Disrupt any of those long enough, and complexity can collapse. Not all at once, but piece by piece. Skills are lost, networks break down, knowledge becomes harder to pass on. History gives us small examples. Societies that fell and were followed by periods of simplification, writing forgotten, engineering techniques lost, populations scattered. Over time, stories replace records, myths replace explanations, practical knowledge becomes legend. Scale that process up, stretch it across tens of thousands of years, add planetary forces. The result doesn't look like ruins waiting to be discovered. It looks like silence. None of this means that earlier civilizations definitely existed, but it does mean that the certainty with which we dismiss the idea may be less solid than it feels. Earth is not a museum carefully preserving every phase of life. It is an active system constantly reworking itself. We are living in one of its brief windows of relative stability. Warm enough, calm enough, predictable enough to allow complex societies to grow. That window has opened and closed many times before. For now, there's no conclusion to draw. Just a question left resting comfortably in the background, like a thought you don't need to answer before sleep arrives. What if this has happened before? And what if Earth is very, very good at starting over? It feels natural, almost instinctive, to assume that we are the first to build cities that stretch across landscapes, the first to shape materials into complex machines, the first to organize ourselves into systems that reach far beyond family or tribe. This assumption sits quietly in the background of modern life, rarely questioned, because it fits so neatly with the story we've been taught from a young age. History begins in a tidy place, progresses step by step, and arrives at us. We are the latest chapter, the most advanced point so far, standing at the front edge of time. That belief is comfortable. It gives us a sense of direction. It suggests that progress is linear, that complexity only moves one way, and that everything behind us is simpler, less capable, and less significant. It allows us to look at the past as a long preparation phase, a slow climb toward the present moment. And it reassures us that the world we live in now is not only new, but unprecedented. Yet comfort and truth are not always the same thing. The idea that we are the first civilization depends on a very specific definition of civilization itself. Usually it means large permanent settlements, agriculture, written language, specialized labor, and complex social organization. These criteria are useful for classification, but they are also selective. They privilege what is easiest to identify archaeologically, not necessarily what is most likely to have existed. Writing, for example, is treated as a dividing line between prehistory and history. Once writing appears, events become easier to trace. Names are recorded, dates are marked, stories become fixed. But writing is not the same as intelligence, nor is it the same as organization. It is simply one method of preserving information, and not a particularly durable one unless conditions are just right. Most writing surfaces decay quickly. Papyrus rots, parchment decomposes, ink fades. Even clay tablets, often held up as durable, are fragile unless fired and protected. If a society used materials that didn't fossilize well, its written record could vanish almost entirely, leaving behind no clear boundary between silence and story. Agriculture, too, is treated as an obvious step toward civilization, but it is not inevitable. Farming is efficient in some environments and risky in others. It ties people to specific locations and makes them vulnerable to climate shifts, pests, and soil exhaustion. A society with advanced ecological knowledge might deliberately avoid large-scale agriculture, choosing mobility or mixed subsistence instead. Such a choice wouldn't make them less organized or less intelligent, only harder to detect after long periods of time. Permanent buildings are another expectation. Stone cities endure. Mud brick cities erode. Wooden cities disappear almost completely. Many modern structures, despite their scale, rely heavily on materials that degrade rapidly once maintenance stops. Without continuous repair, even reinforced concrete fractures and crumbles. Given enough time, forests reclaim foundations, rivers change course, sediment buries everything evenly. The assumption that we are the first also rests on a deeper belief about human nature, that early humans were primarily concerned with survival, that higher organisation required long, gradual improvement, and that intelligence only blossomed recently. This belief persists despite growing evidence that humans have been cognitively similar to modern people for at least 200,000 years. The brains were there, the capacity for language was there, social complexity was there. What varied were circumstances. Environment shapes behaviour. Stability allows accumulation. Repeated disruption favours flexibility over permanence. If earlier populations lived through frequent climate swings, advancing ice, retreating ice, flooding coastlines, drying interiors, then long-lasting centralised systems may have been less practical. Civilization, in that context, wouldn't look like a steady climb. It would look like cycles of experimentation, adaptation, loss, and reorganisation. This brings us to another comforting assumption, that progress once achieved is never fully lost. History doesn't support that idea very well. Within recorded history alone, we see examples of technological and cultural regression, knowledge that disappears, skills that fade, techniques that must be rediscovered centuries later, writing systems lost and reinvented, engineering methods abandoned, entire populations reduced to oral tradition after previously maintaining complex bureaucracies. These collapses didn't happen because people became less intelligent. They happened because systems failed. Trade routes broke down, climate shifted, resources became scarce, social cohesion fractured. Once complexity falls below a certain threshold, maintaining specialised knowledge becomes difficult. A community focused on immediate survival has little capacity to preserve abstract or technical information. Now stretch that process across thousands of years without written records. Stretch it across planetary events. The idea that a civilization could rise, fall, and leave behind only faint traces stops sounding unreasonable. The reason the first civilization narrative feels so solid is because it aligns with our own position in time. We can trace a continuous line backward from ourselves through known cultures, technologies, and artifacts. That continuity gives us confidence, but continuity is only visible where it exists. Where it breaks, we tend to assume nothing was there before. Silence is easy to mistake for emptiness. There is also a psychological comfort in believing that we are unique, that our moment in history is special, that we occupy a privileged position as the first to understand the universe, the first to manipulate nature at scale, the first to ask certain questions. This belief feeds into narratives of destiny and progress. It reinforces the idea that the past was leading inevitably toward us. Questioning that assumption can feel unsettling. If we are not the first, then we are not the culmination. We become one iteration among many, a phase rather than a pinnacle. That shift doesn't diminish human achievement, but it reframes it. It suggests fragility rather than inevitability. Another reason the assumption persists is practical. Archaeology, by necessity, works with what can be found. It reconstructs history from fragments. The absence of evidence is not usually treated as evidence of absence, but over time, repeated absence hardens into expectation. If something had existed, we tell ourselves, we would have found it by now. But archaeology covers a tiny fraction of Earth's surface in detail. Vast regions remain unexplored or poorly studied. Much of the seafloor is still unmapped at high resolution. Dense forests conceal sites. Urban development destroys layers of history before they can be examined. Political instability limits access. Funding shapes priorities. Even when evidence exists, interpretation matters. Anomalies are often explained in the safest possible way. A tool that seems too advanced for its age is reclassified. A structure that doesn't fit expectations is attributed to natural processes. This is not deception. It is caution. Science is conservative by design. Extraordinary claims require extraordinary evidence, yet caution has a side effect. It favours familiar explanations. It reinforces existing frameworks. The idea that civilization has happened only once fits comfortably within established models. It doesn't require rethinking timelines, methodologies, or assumptions about human behaviour. Comfort, again, plays a role. There is also the problem of scale. Civilization, as we imagine it, often implies large populations and visible impact. But size is not the only measure of complexity. A smaller population with advanced knowledge, social coordination, and sustainable practices could leave a lighter footprint than a larger, resource-intensive society. That lighter footprint would be harder to detect, especially after long periods of geological activity. We also tend to project our own values backward. We assume earlier societies would strive for expansion, monument building, and material accumulation. But values are shaped by context. A society emerging after repeated environmental disruptions might prioritize resilience over growth, redundancy over scale, memory over monumentality. Such a civilization would not announce itself loudly to the future. It's worth noticing how often our certainty about being first relies on what hasn't been found rather than what has. We are confident because there are no obvious remains of ancient global industry, no layers of plastic millions of years old, no unmistakable signs of prior technological epochs. But even our own era may not leave such clear markers over deep time. Plastics break down, metals disperse, chemical signatures dilute, nuclear isotopes decay. Given enough time, the most distinctive traces of modern industry could fade into background noise, especially if followed by significant geological upheaval. This doesn't mean Earth would forget us entirely. It means the record would become ambiguous. Future investigators might find unusual concentrations of certain elements, abrupt changes in sediment composition, or brief anomalies in climate data. Interpreting those signs as evidence of civilization would require context, and context is fragile. The comfortable assumption that we are the first is not foolish, it is understandable. It arises from the evidence we have, the methods we use, and the stories we tell ourselves about progress. But comfort should not be mistaken for certainty. When people talk about the distant past, they often compress it without realizing they are doing so. 10,000 years ago feels unimaginably remote. 100,000 years ago feels almost abstract. Beyond that, the mind tends to blur everything into a single category called ancient, as though time itself stops having texture once it stretches far enough. This is where deep time begins to lose its grip on everyday intuition, not because it is unknowable, but because it is too large to fit comfortably into the way we normally think. Deep time is not just a long time ago. It is a scale so vast that familiar reference points stop working. Written history occupies only a thin surface layer. Even the earliest stone tools, impressive as they are, represent only brief flashes in a timeline dominated by silence. Most of Earth's story unfolds without witnesses, without records, without anything resembling memory in the human sense. Between stone and steel there are stretches of time longer than all recorded history combined, and in those stretches very little speaks to us directly. The geological record is not a diary. It does not record intentions, conversations, or plans. It records pressure, heat, movement, erosion, and chemical change. It remembers volcanoes and glaciers far more faithfully than it remembers lives. A mountain range leaves a clearer signature than a city. A floodplain tells its story more clearly than a community that lived along its banks. This is why deep time is so quiet. Stone tools survive because stone resists decay. Bone survives occasionally, under specific conditions. Fired clay sometimes lasts. Everything else is conditional. Wood disappears, fibers vanish, food leaves no trace. Human voices, ideas, agreements, and systems leave nothing physical at all, unless deliberately encoded in something durable. When we imagine earlier civilizations, we often imagine their ruins frozen in time, waiting patiently to be uncovered. But that image comes from places where time slowed down, where dry climates or sudden abandonment preserved structures. Most of Earth is not like that. Most of Earth is active, wet, shifting, grinding, dissolving, rebuilding itself continuously. Rivers do not respect foundations. They wander, they undercut, they bury. Coastlines migrate, forests push through stone, microorganisms dismantle materials molecule by molecule. Given enough time, even the most solid structure becomes sediment. Steel feels permanent because it outlasts a human lifespan. In deep time, steel is brief. It oxidizes, it flakes, it fractures. Buried steel corrodes faster than exposed steel. Eventually it disperses into the surrounding soil, leaving only subtle changes in chemistry. Without context, those changes are meaningless. Stone lasts longer, but even stone is temporary. Tectonic plates recycle crust back into the mantle. Sedimentary layers compress, heat, and transform. What once was a surface becomes deep underground. What once was deep rises again somewhere else, altered beyond recognition. This means that the silence between stone and steel is not empty. It is erased. Archaeology works within narrow windows of preservation. It depends on lucky accidents. A site must be abandoned quickly. It must avoid later construction. It must escape erosion. It must be discovered before being destroyed. Every known site represents an improbable survival. Most sites do not survive. Now consider how brief technological phases can be. Stone tools appear, change, disappear, reappear. Metalworking emerges, spreads, collapses, returns. Writing systems bloom and vanish. Entire ways of organizing society rise and fall within spans that barely register geologically. If a civilization existed before the last major ice ages, its surface remains would have been ground away by advancing ice sheets in many regions. In others, they would be buried under meters of sediment from melting glaciers. Along coastlines, they would be submerged. In tectonically active zones, they would be folded, fractured, or melted. The gaps between stone and steel, then, are not just technological gaps. They are gaps in preservation. We often imagine a smooth progression. Stone tools gradually refined, then pottery, then metals, then cities. But deep time does not demand smoothness. It allows for repetition. It allows for experimentation that does not lead forward in a straight line. A society could develop advanced knowledge, then lose it. Another could arise elsewhere with different priorities. These cycles could occur without leaving a continuous chain of artifacts linking them together. One reason this idea feels uncomfortable is because it undermines chronology as a narrative of progress. It suggests that development is not guaranteed, and that complexity is fragile. In deep time, fragility matters more than achievement. There is also the issue of scale in detection. Archaeology is excellent at finding small things made of durable materials. It struggles with large things made of fragile ones. A stone hand axe survives better than a wooden building. A flint blade outlasts a woven structure. A ceramic shard speaks louder than a sophisticated system that left no durable parts. This biases our picture of the past. It makes early humans appear simpler than they may have been, because we see only what survives, not what existed. Imagine trying to reconstruct modern civilization from what would survive after 50,000 years without maintenance. You might find scattered stone foundations, odd mineral concentrations, a few strange alloys, perhaps traces of large-scale burning. The story would be incomplete and confusing. Now imagine trying to reconstruct a civilization that intentionally avoided durable construction, favoured biodegradable materials, and lived in harmony with changing environments. The record would be almost non-existent. Deep time also introduces another complication. Time itself smooths patterns. Sharp boundaries blur, distinct layers mix. A site from one period may be disturbed by later activity. Materials migrate vertically through soil. Burrowing animals, roots, freeze-thaw cycles all move objects out of their original context. Context is everything in archaeology. Without it, artifacts lose meaning. A tool found out of place is just a rock until proven otherwise. This is why silence dominates deep time. Not because nothing happened, but because the mechanisms that preserve stories are weak compared to the forces that erase them. The phrase Stone Age itself reflects this bias. It names an era after what survives, not after what defined daily life. Stone tools were important, but they were not the whole world. They were the durable leftovers of societies that likely relied heavily on wood, fibre, leather, plant knowledge, and social structures we can barely glimpse. Between stone and steel, there were minds just as capable as ours. People observed the sky. They tracked seasons. They remembered landscapes. They passed down knowledge orally with precision. Oral cultures can preserve complex information for thousands of years when uninterrupted. But interruption was common. Climate shifts forced migrations. Ice advanced. Deserts expanded. Coastlines vanished. Communities scattered. Oral chains broke. Knowledge fragmented. Deep time does not favour continuity. Another quiet assumption we carry is that technology leaves obvious markers, but technology is not always material heavy. Knowledge can be procedural, social, embedded in practices rather than objects. A society could master navigation without leaving maps, medicine without leaving instruments, engineering without leaving monuments. If those practices disappear, they leave little behind. Even today, much of what makes modern civilization function is invisible. Software, networks, agreements, protocols. Remove electricity and most of it vanishes without trace. Deep time does not preserve servers or signals. The silence between stone and steel is therefore not a blank canvas. It is a palimpsest, written and rewritten so many times that earlier layers are nearly impossible to read. This does not mean that evidence of earlier civilizations is hiding everywhere, waiting to be recognized. It means that the absence of clear evidence is expected under deep time conditions. It is the default outcome, not an anomaly. Geology remembers the slow and the violent. It forgets the subtle and the brief. When we look back and see long periods with few artifacts, we often label them stagnant or uneventful. But that interpretation comes from silence, not from observation. We're hearing what the record can hold, not what life contained. Deep time humbles certainty. It reminds us that our window of observation is narrow. It warns us against overconfidence based on incomplete data, and it invites a different kind of curiosity, one that accepts uncertainty without rushing to fill it. Civilizations leave traces whether they intend to or not. Every organized human activity nudges the environment in small cumulative ways. Paths become compacted soil. Hearths alter chemical signatures. Waste accumulates. Structures displace material. Even simple habitation changes pollen records, fire frequency, and animal populations. Nothing leaves the world exactly as it was found, and yet, the presence of traces does not guarantee their survival. The way civilizations leave evidence is deeply uneven. Some actions carve loudly into the planet. Others whisper. Some traces endure for millennia. Others vanish within decades. What remains visible to the distant future is shaped less by importance than by durability, timing, and chance. Stone is remembered because stone resists change. Fired clay earns a similar privilege. Bone sometimes survives. Everything else negotiates with time, moisture, temperature, pressure, biology, and geology. That negotiation is rarely fair. When archaeologists reconstruct past societies, they work with what persists, not with what mattered most to the people who lived there. This creates a subtle distortion. Daily life, relationships, beliefs, Knowledge systems and decision-making processes often leave no physical mark at all. The material record is partial by nature. It is not a balanced archive. Take buildings, for instance. Monumental stone architecture survives better than anything else, which is why civilizations that built with stone appear more prominent in the historical imagination. But stone construction is resource-intensive, labour-heavy, and not always practical. Many societies built primarily with wood, earth, plant fibres, and other materials that return quickly to the environment once abandoned. A wooden city can vanish almost completely within a few centuries. A mud brick settlement erodes back into soil. A woven structure leaves nothing. Without continued maintenance, even advanced construction dissolves quietly. Metal seems more promising, but metal is deceptive. Iron rusts aggressively. Copper corrodes. Bronze fragments. Buried metal reacts chemically with its surroundings, especially in moist soils. Over long periods, metal disperses into the environment as oxides and salts, becoming indistinguishable from naturally occurring minerals. Without context, it loses its meaning. Technology, as we imagine it today, feels heavy and permanent. Factories, infrastructure, machines. But permanence is an illusion created by maintenance. The moment systems stop being supported, decay begins immediately. Pipes clog, roads crack, electrical systems fail, mechanical components seize. Within a few centuries, most modern infrastructure would be rubble. Within a few thousand years, it would be difficult to identify. Even large-scale industry leaves surprisingly subtle long-term markers. Chemical pollution disperses, landfills erode, plastics break down into smaller fragments, then smaller still. Radioactive signatures decay. What feels overwhelming now becomes faint noise against geological processes. There are exceptions. Sudden burial can preserve detail. Volcanic ash can freeze moments in time. Rapid submersion in anoxic conditions can protect organic material. But these are rare events. Preservation depends on luck, not design. Now consider how traces disappear. Erosion is relentless. Wind scours surfaces. Water dissolves, transports and redeposits material. Rivers migrate across floodplains, cutting into old ground and burying it elsewhere. Coastlines shift with sea level. What was once dry land becomes seabed. What was seabed becomes land again. Biology participates enthusiastically in erasure. Plants crack stone with roots. Microorganisms digest organic material. Animals burrow, disturb layers, and move objects out of context. Forests reclaim abandoned ground quickly. Within a few human generations, traces soften. Within many generations, they vanish. Fire also resets landscapes. Natural and human-caused fires consume structures, redistribute nutrients, and erase surface evidence. After enough cycles, only subtle changes remain, detectable only through careful analysis. Then there is geology's long memory and short patience. Sediment accumulates, layers compress. Heat and pressure transform material. Tectonic forces fold, fracture, and recycle crust. Entire regions are abducted into the mantle and remade. Nothing on the surface is guaranteed permanence. This is why deep archaeological gaps are not surprising. They are expected. The traces that do survive are often misleading. A stone tool found in isolation tells us very little. It speaks to manufacture, not to the society that produced it. Without associated context, it cannot tell us how people lived, how knowledge was transmitted, or how communities were organized. Large structures fare better, but only under favorable conditions, and even then, interpretation is fragile. A collapsed wall may look like a natural formation. A modified landscape may resemble erosion. Without comparative data, intentionality is hard to prove. Civilizations that leave the clearest traces are not necessarily the most advanced. They are the ones that used materials that resist time and lived in environments that slowed decay. This creates a skewed historical record, favouring arid regions, stone construction, and sudden abandonment. Now, imagine a civilization that existed during a period of climatic instability, a society that relocated frequently, one that rebuilt rather than repaired, one that used biodegradable materials and left little waste. Its environmental footprint might be detectable in subtle ways, but its physical remains would be minimal. If such a civilization collapsed gradually rather than catastrophically, its traces would disperse slowly, blending into the background. There would be no dramatic layer marking its end, no sharp boundary announcing its disappearance. We often expect civilizations to fail loudly, but collapse is usually quiet. Knowledge fades first, specialization narrows, trade diminishes, population disperses. Eventually complexity simplifies. Tools remain useful but less refined. Memory becomes local. After enough time, what was once civilization becomes tradition, then habit, then instinct. Physical traces do not announce this process, they simply thin out. Another factor rarely considered is reuse. Humans recycle relentlessly. Stone is repurposed, metal is melted and reforged, foundations become quarries. Later societies cannibalize earlier ones, leaving behind a palimpsest of materials divorced from their original context. A city can be dismantled entirely by its successors, its stones incorporated into new structures, its metals reworked, its layout erased. What remains is not absence, but redistribution. Even today, urban development destroys archaeological layers before they can be studied. Countless sites have been paved over, excavated without documentation, or obliterated by construction. The deeper past has suffered this process many times over. It is also important to recognize that not all traces are material. Some are environmental, shifts in vegetation patterns, changes in fire regimes, alterations in animal populations. These can indicate human influence, but they rarely point clearly to organized civilization rather than dispersed activity. Distinguishing between sustained, complex society and extended human presence is difficult. Both modify environments, both leave footprints. The difference lies in scale and structure, not always in obvious markers. This ambiguity fuels certainty on one side and speculation on the other. Without unmistakable ruins, many conclude that nothing complex existed. Without direct evidence, others imagine elaborate lost worlds. Both positions risk overconfidence. A more grounded view accepts uncertainty as part of the landscape. Civilizations do not leave neat signatures. They leave uneven scars, faint residues, and patterns that require interpretation. Over deep time, those patterns blur. Earth is not an archive designed for clarity. It is an active system optimized for change. The question then is not whether civilizations leave traces. They always do. The question is how long those traces remain legible, and to whom. We are excellent at recognizing what looks familiar. We struggle with what does not. If earlier civilizations organized themselves differently, prioritized different materials, or operated under different constraints, their traces might not announce themselves as civilization at all. They might look like anomalies, outliers, noise. Memory feels solid when it lives inside a human mind. You remember where you were yesterday, what you said, what you planned. Shared memories feel even stronger. Stories passed through families, traditions repeated across generations, written records stored in libraries. It all creates the impression that once something is known, it stays known. That once something happens, it becomes part of an ever-growing archive called history. But memory, beyond the scale of individuals or even cultures, is far more fragile than it appears. On a restless planet like Earth, memory is not preserved by default. It must fight constantly against forces that do not care whether something was important, meaningful, or transformative. Earth remembers pressure, heat, movement, and chemistry. It does not remember intention. It does not remember achievement, and it does not remember stories unless they are carved into materials that can survive its cycles. What we call memory, at a planetary scale, is really just residue that escaped erasure long enough to be noticed. Human memory depends on continuity. Someone must remember, then teach, then repeat. Cultural memory depends on stable populations, shared language, and uninterrupted transmission. Once those chains break, memory collapses quickly. Within a few generations, detailed knowledge can vanish entirely, leaving behind fragments that no longer explain themselves. Earth does not provide continuity, it provides interruption. Climate shifts alone are enough to fracture memory. A prolonged drought forces migration. Migration separates groups. Separation alters language. Altered language reshapes stories. Stories lose precision. Meanings drift. What once described specific events becomes symbolic. What once recorded knowledge becomes myth. Ice ages are especially efficient at this. During glacial periods, vast regions become uninhabitable. Populations retreat to refuges. Numbers shrink. Diversity narrows. Survival becomes the priority. Under those conditions, memory is not curated. It is trimmed aggressively. Only what is immediately useful survives. When the climate warms again, people expand outward into new landscapes. But they do not carry everything with them. They carry what fits into limited memory and daily necessity. The rest is left behind, not deliberately, but inevitably. Over repeated cycles, memory thins. This is why oral traditions, as impressive as they are, have limits. They can preserve genealogies, laws, and ecological knowledge with remarkable accuracy over centuries or even millennia. But they require stable transmission. Break the chain often enough and precision dissolves. Written memory seems stronger, but it is also vulnerable. Writing depends on materials. Materials decay. Archives burn. Floods destroy libraries. Empires fall and records are deliberately erased or neglected. Languages die, rendering text unreadable even when they physically survive. There are countless written records that exist but cannot be understood because the context that gave them meaning is gone. Symbols persist, but their references are lost. Without a key, writing becomes pattern without content. This fragility compounds over time. Earth itself accelerates forgetting. Landscapes shift in ways that disrupt human reference points. Rivers change course, erasing settlements built along their banks. Coastlines migrate, swallowing ports and harbours. Forests grow where fields once were. Deserts expand over former grasslands. A place remembered in stories may no longer exist in recognisable form. The mountain described by ancestors may have eroded. The lake may have drained. The path may lie beneath sediment. Memory tied to place loses its anchor. Even when physical traces survive, they are often divorced from meaning. A foundation remains, but who built it, why, and how it functioned are unknown. An artifact survives, but its role in daily life is unclear. Without explanation, objects become mute. The restless nature of Earth ensures that memory, once externalized, is always temporary. Geological processes operate on timescales that dwarf cultural ones. A civilization might last thousands of years, and still be nothing more than a brief surface disturbance from a geological perspective. What survives beyond that is not chosen. It is filtered. Memory also suffers from selection bias. What we remember collectively is shaped by what can be preserved, not by what mattered most. Entire domains of knowledge leave no trace. Conflict leaves clearer marks than cooperation. Monument building leaves more evidence than governance. War preserves itself better than peace. This shapes our understanding of the past in subtle ways. We see fortifications and weapons more clearly than social systems. We find tombs more easily than marketplaces. We reconstruct hierarchy better than daily life. The picture we assemble is incomplete, but it feels whole because it is all we have. On a restless planet, memory does not accumulate neatly, it fragments. Another overlooked factor is time compression. When events are separated by long intervals, later observers tend to compress them into single narratives. Distinct cultures blur together. Separate collapses appear as one. Multiple migrations are remembered as a single movement. This happens even within recorded history. Events separated by centuries are spoken of as if they were connected directly. In deep time, this compression becomes extreme. Thousands of years collapse into vague eras. Subtle shifts vanish entirely. If civilization arose, fell, and arose again in different forms, separated by long intervals of disruption, memory would not record it as repetition. It would record it, if at all, as scattered, disconnected anomalies. Myths may be one of the few forms of memory that survive long enough to cross these gaps, but myths are not literal records. They encode experiences in symbolic form. Flood stories may preserve memories of rising seas. Fire myths may recall volcanic events. Stories of lost golden ages may echo periods of stability followed by collapse. But myths adapt to new contexts. They absorb local meaning, they shift emphasis. Over time, they stop pointing clearly to their origins. They become flexible containers rather than fixed records. This does not make them useless, it makes them ambiguous. A restless planet also reshapes memory through catastrophe. Sudden events can erase vast amounts of information at once. Volcanic eruptions bury regions. Tsunamis sweep coastlines clean. Impacts alter climate globally. These events do not just destroy infrastructure, they destroy continuity. After catastrophe, survivors rebuild from fragments. Knowledge gaps appear, skills are lost. What remains is what can be relearned quickly. Long-term projects are abandoned. Specialized knowledge fades. The deeper the disruption, the more radical the forgetting. Over geological timescales, Earth has experienced repeated global or near-global disruptions, some abrupt, some gradual, all capable of resetting ecological and cultural systems. In that context, expecting memory to persist cleanly across deep time is unrealistic. Even today, with global communication and redundant storage, memory is fragile. Data formats become obsolete. Digital media degrade. Knowledge depends on infrastructure. Remove electricity, and much of our collective memory becomes inaccessible almost instantly. Future memory is not guaranteed simply because information exists now. There is also a human tendency to underestimate forgetting. We imagine memory as cumulative, building layer upon layer. In reality, it behaves more like a sieve. Most information passes through. Only a small portion is retained, and even that portion is altered. On a planetary scale, the sieve is enormous. This reframes how we think about absence. A lack of remembered civilizations does not mean none existed. It means that if they did, their memory was not protected against the forces that dismantle information. Earth is not an archivist. It is an editor with a very aggressive delete function. Understanding this fragility does not require believing in lost advanced civilizations. It simply requires accepting that memory is not a stable property of the planet. It is a temporary state maintained by continuous effort. Remove the effort, and memory dissolves. What we inherit from the past is therefore not a complete record, but a survivorship bias. We see what endured, not what dominated. We reconstruct stories from leftovers, not from full inventories. This should encourage humility rather than certainty. Long before satellites traced coastlines from orbit, before maps fixed borders in ink, and before cities announced themselves with towers and lights, human settlements followed quieter rules. People gathered where water flowed, where soil renewed itself, where forests offered shelter and coastlines provided food. These choices made sense then, just as they do now. They also placed many settlements directly in the path of Earth's most active erasing forces. Forests grow, sands move, seas rise. None of them are gentle with memory. When we imagine lost cities, the mind often jumps to dramatic ruins standing proudly against time, stone walls half buried but unmistakable. That image is misleading. Most lost cities are not dramatic. They are quiet. They are flattened, dissolved, scattered, or buried so thoroughly that even their absence feels natural. The environments that best support human life are often the same environments that excel at hiding its traces. Forests are one such environment. Dense vegetation conceals ground features quickly. Roots pry apart stone. Soil builds up layer by layer as leaves fall and decay. Microorganisms break down organic material with relentless efficiency. Within a few centuries, structures that were once clearly defined soften into irregular ground. Within a few thousand years, even large settlements can disappear beneath forest floors, leaving only subtle disturbances in soil chemistry or elevation. For a long time, archaeologists underestimated how much forest could hide. Thick canopies limit visibility. Excavation is difficult and slow. Traditional survey methods miss features masked by vegetation. As a result, many forested regions were assumed to hold little evidence of large-scale settlement. That assumption has proven incorrect. In recent decades, technologies like LIDAR have peeled back forest cover virtually, revealing landscapes shaped extensively by human hands. Networks of roads, terraces, canals, and urban centres have emerged from beneath jungle canopies, in places where only scattered ruins were previously known. These discoveries do not suggest primitive habitation. They suggest planning, coordination, and sustained occupation over long periods. What is striking is not just that these cities existed, but how completely they vanished from view. Without LIDAR, many would still be invisible. The forest did not preserve them, it absorbed them. Now consider how many forested regions remain unexplored or only partially surveyed. Tropical forests cover vast areas of the planet. Many are politically unstable, environmentally protected, or logistically challenging. Even with modern tools, coverage is incomplete. The idea that all significant ancient settlements in these regions have been found is not realistic. Forests are efficient erasers because they are dynamic. They grow, fall, regrow, they churn soil, they recycle nutrients, they close over gaps. Over long periods, they smooth human geometry back into organic randomness. Sands operate differently, but with equal effectiveness. Deserts are often imagined as preservers, places where dryness protects ruins. In reality, many deserts are highly mobile systems. Sand dunes migrate, wind scours surfaces, fine particles infiltrate structures and undermine them from within. What is not buried is abraded. What is buried is crushed and compacted. Settlements built on the edges of deserts are especially vulnerable. As climates shift, grasslands can turn to arid zones. Water sources dry up. Populations leave. Without maintenance, structures weaken. Then sand moves in, not all at once, but steadily. A city swallowed by sand does not leave a dramatic boundary. It leaves layers. Walls collapse inward. Roofs cave. Streets fill. Over time, the city becomes a low rise beneath dunes. From the surface, it looks like uninterrupted desert. Occasionally, wind uncovers fragments. A wall here, a doorway there. These finds feel mysterious because they emerge from places assumed to be empty. But they are reminders that deserts were not always deserts. Climate oscillations have repeatedly expanded and contracted arid zones, transforming inhabited landscapes into seemingly timeless emptiness. When people speak of the world's great deserts as eternal, they overlook this movement. The Sahara, for example, has been green multiple times in the recent geological past. Rivers flowed, lakes existed, vegetation supported wildlife and people. As the climate shifted, those systems collapsed. Sand replaced soil, memory vanished with the water. Any settlements built during those greener phases now lie buried, eroded, or dispersed. Their absence is not evidence of non-existence, it is evidence of environmental change. Then there are the seas. Rising sea levels have erased more human history than any other single process. During the last ice age, when much of Earth's water was locked in ice sheets, sea levels were dramatically lower. Coastlines extended far beyond their present positions. Continental shelves that are now submerged were once dry land, rich with resources and ideal for settlement. Humans are drawn to coasts, they always have been. Access to marine food, transportation routes, and relatively stable climates make coastlines attractive. It is reasonable to assume that as people spread across the world, they concentrated heavily along these now submerged plains. When ice melted and sea levels rose, those settlements were drowned. Some were inundated slowly, giving inhabitants time to retreat. Others may have been overwhelmed by rapid flooding events. In either case, the sea claimed them. Underwater archaeology is challenging. Visibility is limited. Sediment shifts. Biological growth obscures structures. Currents scatter debris. Even large features can be difficult to identify unless specifically targeted. The ocean floor is vast and only a small fraction has been examined in detail. What we do know is that submerged landscapes exist everywhere. River valleys now lie beneath the sea, ancient shorelines have been mapped. Stone tools and habitation sites have been found underwater in various regions, often accidentally during construction or fishing. These finds suggest presence, not scale. They hint at lost worlds rather than documenting them fully. Now consider the combined effect. Forests hide, sands bury, seas drown. These processes do not act in isolation. Over deep time, a settlement might experience all three. A coastal city is flooded, then sedimented, then uplifted, then forested, then eroded again. Each phase strips context and clarity. Even when traces survive, they are fragmented. There is also the issue of recognition. A buried city does not announce itself as a city. It appears as anomalies. Unusual stone alignments, odd soil layers, unexpected concentrations of artifacts. Without a reason to look closely, these anomalies are often missed or dismissed. Our expectations shape what we see. If we expect only small, scattered settlements in deep prehistory, we're less likely to interpret large-scale features as intentional. A grid might look like geology. A terrace might look like erosion. A canal might look like a natural channel. Interpretation requires a framework. Without one, evidence stays ambiguous. Lost cities beneath forests, sands, and seas challenge the idea that civilization must leave obvious, indestructible markers. They show that even large, organized societies can vanish almost completely under the right conditions, not instantly, gradually, quietly. This does not mean that every forest hides a metropolis or every desert conceals an empire. It means that the environments most capable of supporting complex human life are also among the most effective at erasing it. There is another subtlety here. Loss does not require catastrophe. It requires neglect. When maintenance stops, decay begins. Cities are not static objects. They are processes. Remove the process, and the object dissolves. A forest does not need to attack a city. It only needs time. The same is true for sand and sea. They do not destroy out of malice or violence. They move according to physics. Humans build in the paths of these movements because those paths are attractive at certain times. Later, when conditions change, the same paths become destructive. This makes the record uneven. Regions with stable climates and low geological activity preserve more. Regions with dynamic environments preserve less. That unevenness feeds into our narratives about where civilization did and did not exist. It also feeds into certainty. When we look at maps of known ancient cities, patterns emerge. We see clusters. We see apparent centres of development. But those patterns may reflect preservation bias as much as historical reality. Where memory survives, we see history. Where memory dissolves, we see emptiness. Empty on the map does not always mean empty in the past. As technology improves, glimpses of hidden landscapes continue to emerge. Each discovery reshapes assumptions slightly. None overturn everything. But together, they suggest that the surface record is incomplete in systematic ways. Lost cities beneath forests, sands, and seas do not prove that civilization has happened many times. They do something quieter and more important. They demonstrate that large-scale human organization can disappear almost entirely under ordinary planetary processes. They show that erasure does not require mystery, only time, movement, and change. Cities not falling in flames but slowly dissolving into leaf litter, sand grains, and sediment. Not lost in a single moment, but thinned until nothing recognizable remains. Earth does not need drama to forget. It only needs patience. Ice does not negotiate. It does not pause to preserve what lies beneath it, and it does not distinguish between the natural and the human-made. When ice advances, it presses, scrapes, fractures, and carries away. Over long spans of time, this single process has been one of the most powerful reset mechanisms the planet has ever deployed. Entire landscapes have been rewritten under ice, not once, but many times, and each pass has quietly simplified the surface story of Earth. Ice ages are often imagined as distant, singular events, something dramatic but brief, like a curtain closing once in the deep past. In reality, they are cyclical and persistent. Over the last several million years, Earth has oscillated between colder and warmer phases again and again. Ice sheets expanded, retreated, then returned, sometimes covering much of the northern continents to depths measured in kilometers. These were not gentle blankets. They were slow-moving machines. A continental ice sheet behaves less like frozen water and more like a viscous solid. It flows outward under its own weight, deforming rock beneath it, bulldozing loose material ahead of it, and grinding everything it passes over into finer and finer particles. Mountains are shaved down, valleys are deepened, plains are scoured flat. What survives is not what was important, but what was deeply buried or geographically fortunate. Any surface structure in the path of advancing ice is effectively erased. Wooden buildings are crushed and pulverized. Stone constructions are fractured and transported. Roads, walls, and foundations are torn apart and smeared across the landscape as debris. Even bedrock does not emerge unscathed. It is polished, striated, and reshaped, losing fine features that once recorded surface history. When the ice retreats, it does not return what it took. It leaves behind a rearranged world. Thick layers of glacial till blanket the ground. Massive erratic boulders sit far from their origins. Meltwater carves new river systems that bear little resemblance to what existed before. Lakes appear where none were before. Soil profiles are reset. From the perspective of memory, an ice age is not just a cold period, it is a massive editing event. Consider what this means for any human presence that predated a major glaciation. If people lived in northern latitudes during warmer intervals, built settlements, altered landscapes, or developed complex systems, those efforts would have been wiped clean by advancing ice. Not buried neatly, destroyed mechanically. This is not speculation. We can observe the results directly. Large portions of North America and Northern Europe show clear signs of glacial scouring. The surface geology in these regions has been stripped of older layers. In many places, the sedimentary record above bedrock begins only after the last glacial retreat. Anything that existed on the surface before that is gone. This creates a sharp boundary in the archaeological record. In glaciated regions, evidence rarely extends far beyond the most recent ice age. This absence is often interpreted as absence of occupation, but it is equally, and more plausibly, absence of preservation. Ice does not preserve cities, it does not archive tools, it does not remember paths. Now consider how long these glacial cycles last. The last major ice age peaked around 20,000 years ago, but ice sheets began advancing long before that. Previous glaciations occurred repeatedly over hundreds of thousands of years. Each cycle erased surface history again, then again, then again. If civilization requires only a few thousand years to emerge under favourable conditions, there were many windows between glaciations where such development could have occurred. Each window ended the same way. Ice advanced. Memory ended. One might argue that humans simply were not present in large numbers during those earlier periods. But this argument assumes a linear expansion model that may not reflect reality. Human populations expanded, contracted, migrated, fragmented, and recombined repeatedly in response to climate pressures. Some groups moved south, others adapted locally, some vanished entirely. What matters here is not population size, but the fate of evidence. Ice ages favour survival strategies that leave minimal material trace. Mobility becomes essential. Permanent structures become liabilities. Knowledge becomes portable and oral. Social organisation tightens. In such conditions, even a sophisticated society would leave little behind, and what it did leave would be scraped away later. Ice also disrupts continuity in a subtler way. It forces bottlenecks. Populations retreat into refugia, isolated regions where climate remains tolerable. Genetic diversity narrows, cultural diversity narrows, knowledge systems compress. When the ice retreats and expansion resumes, the world is repopulated by fragments of what existed before, not the whole. This process does not merely remove traces, it reshapes humanity itself. After each glacial retreat, humans encountered landscapes that were effectively new. Fresh soils, newly formed rivers, altered coastlines, changed ecosystems. Even if memories of earlier worlds survived in stories, the physical reference points were gone. Knowledge tied to place became obsolete. Imagine a society that once navigated a river system that no longer exists, or farmed land now buried beneath glacial deposits, or lived along a coastline now submerged far offshore. The memory of those places would quickly lose practical meaning. Ice ages also alter sea levels dramatically. As ice sheets grow, sea levels drop. As they melt, sea levels rise. This process exposes and then floods vast areas of land. Coastal plains become habitable, then disappear beneath the ocean. Any settlements built during low sea level periods are later drowned. This means that an ice age reset is often followed by a sea level reset. Two erasing processes, one after the other. The combined effect is powerful. First, ice scrapes the continents clean. Then, melting ice rearranges coastlines and submerges former habitation zones. The record is not just thinned, it is redistributed and obscured. Even inland regions are transformed. Meltwater from retreating glaciers creates massive floods. These floods carve new channels, deposit thick sediments, and erase fine-grained evidence. In some cases, entire valleys are reshaped in short geological moments. These are not rare events, they are standard features of glacial cycles. From the standpoint of deep time, ice ages are not anomalies. They are the norm of the recent geological past. Warm, stable periods like the one we currently inhabit are interglacial intervals. They are temporary. This has profound implications for the persistence of civilization. Our current global society exists during a relatively mild and stable climate phase. Sea levels have been high and stable for thousands of years. Ice sheets are limited. Ecosystems have settled. This stability allows long-term planning, permanent infrastructure, and cumulative complexity. But this stability is not guaranteed indefinitely. It is a pause, not a permanent condition. Looking backward, it becomes easier to see how previous pauses could have supported complex development, only to have that development erased when conditions shifted. Each ice age would act not as a single disaster, but as a prolonged process of attrition and erasure. The world after an ice age does not remember the world before in any straightforward way. Another important factor is how ice redistributes material. Glaciers transport debris over long distances. Stones, soil, and fragments from one region are deposited hundreds of kilometers away. This mixing confuses origin and context. An artifact displaced by ice loses its association with the place it was made or used. Even if remnants survive, they may be found out of context, leading to misinterpretation or dismissal. This is one reason why isolated anomalies are often difficult to explain. A tool appears where it does not seem to belong. A structure sits atop geology that does not match expectations. Without understanding glacial transport, such finds can seem implausible. Ice is a great randomizer. It is also selective. Regions near the equator experience less direct glacial coverage, though they were not immune to climate effects. These regions may preserve older records more effectively, but they also face other challenges: dense vegetation, high erosion rates, biological activity, human reuse. No environment offers perfect preservation. Ice ages simply make the problem more obvious. One of the quiet consequences of repeated glaciations is that they bias our understanding of human history towards certain regions and timeframes. Areas spared from heavy glacial scouring appear richer in ancient remains. Areas heavily glaciated appear empty in deep time. This difference is often interpreted culturally, but it is largely geological. The planet has edited the record unevenly. When we ask whether civilization has happened before, ice ages demand humility. They remind us that Earth regularly wipes its slate. They show that surface history is provisional. They explain why long stretches of time appear silent. Silence in this case is not mystery, it is mechanics. This does not mean that earlier civilizations must have existed. It means that if they did, ice ages are one of the most effective ways their traces would be removed. Any hypothesis about deep human history that ignores glacial cycles is incomplete. It is tempting to frame the history of civilization as a story about intelligence, smarter tools, better ideas, more complex thinking. From this angle, progress appears inevitable. Once a species becomes intelligent enough, once it crosses some invisible threshold, civilization follows naturally, and from there, advancement continues forward, accumulating knowledge and capability over time. That framing is reassuring, but it is also misleading. Intelligence, by itself, does not guarantee survival. It does not guarantee continuity, and it does not guarantee that complexity will persist long enough to leave a durable mark on the planet. When viewed across deep time, the rise or disappearance of civilization is far less about how clever a species is, and far more about whether conditions allow that cleverness to be sustained. Humans have been cognitively modern for a very long time. The capacity for abstract thought, symbolic language, planning, cooperation, and creativity did not suddenly appear 10,000 years ago. Anatomically modern humans existed at least 200,000 years ago, and there is strong evidence that their mental capabilities were broadly similar to ours. They told stories, they made art, they understood their environments deeply, they planned across seasons and generations. If intelligence were the limiting factor, civilization should have emerged much earlier and more consistently. The fact that it did not suggests that something else mattered more. Survival is not just about staying alive. It is about maintaining enough stability, population density, and resource predictability for complexity to accumulate. Civilization is fragile because it depends on layers. Agriculture depends on climate stability. Cities depend on food surplus. Specialization depends on reliable exchange. Knowledge systems depend on continuity. Remove any one of these supports for long enough, and the entire structure weakens. Intelligence cannot compensate for an unstable foundation. Consider how narrow the conditions for sustained complexity really are. Temperatures must remain within a tolerable range. Rainfall must be predictable enough to support food production. Sea levels must not rise or fall too rapidly. Ecosystems must not collapse faster than societies can adapt. disease must remain manageable. Population numbers must stay above certain thresholds to preserve knowledge and skills. These conditions have not been constant throughout human history. They have fluctuated dramatically, often on timescales that overwhelm social systems. During periods of climatic instability, the smartest strategy is not building permanence, it is flexibility, mobility, redundancy, cultural practices that prioritize immediate survival over long-term accumulation. Under those conditions, intelligence expresses itself not through monumental architecture or technological escalation, but through adaptability and restraint. A highly intelligent society facing repeated disruptions may deliberately avoid investing in structures or systems that are vulnerable to collapse. That choice would not make them less capable, it would make them less visible to the future. This leads to a common misunderstanding. We often equate lack of preserved complexity with lack of intelligence. But preservation is not a measure of capability, it is a measure of opportunity. Survival pressures shape what intelligence is used for. In a stable environment, intelligence can be channeled into innovation, expansion, and specialization. In an unstable one, intelligence is channeled into endurance, memory compression, and social cohesion. The outputs look very different. There is also the issue of population bottlenecks. When conditions deteriorate, populations shrink. Small populations struggle to maintain complex systems, not because individuals become less intelligent, but because complexity requires scale. Specialized knowledge needs practitioners, infrastructure needs labor, redundancy needs numbers. When populations fall below certain thresholds, societies simplify out of necessity. Skills are lost because there are no longer enough people to practice them. Knowledge disappears because there is no one left to teach it. Over time, the cultural toolkit becomes leaner, focused on what ensures immediate survival. This process can happen surprisingly quickly. Even within recorded history, we see examples of societies losing technologies they once possessed. Techniques that were known and used for centuries disappear when the social conditions that supported them vanish. The knowledge does not fade gradually. It can collapse within a few generations. Multiply this effect across thousands of years and repeated environmental shocks, and it becomes clear that intelligence alone cannot protect complexity. Another overlooked factor is energy availability. Civilization requires energy beyond basic biological needs. Agriculture concentrates energy. Fossil fuels amplify it. But these energy sources are context dependent. They require specific environmental conditions and technological pathways. A society may be intelligent enough to understand energy principles but lack access to dense, exploitable energy sources. Or it may have access but lack the stability to exploit them sustainably. Without surplus energy, large-scale projects become impractical. Energy constraints are survival constraints. Disease also plays a role. Dense populations facilitate innovation, but they also facilitate pathogens. Before modern medicine, epidemics could decimate societies repeatedly. Each wave would reduce population, disrupt continuity, and reset progress. Intelligence does not confer immunity. In fact, increased complexity can increase vulnerability. Trade networks spread disease. Cities concentrate risk. Specialization creates dependencies. When something breaks, the consequences cascade. This creates a paradox. The very features that define civilization also make it fragile. Now consider the timescales involved. Civilization, as we know it, is young. It has existed for a few thousand years in a narrow band of climatic stability. It has not yet been tested by the kinds of disruptions that dominated earlier periods of human existence. We are living in a rare calm interval, not a permanent state. Looking backward, it is entirely plausible that earlier societies reached levels of organization that, while not identical to ours, qualify as civilization in meaningful ways. They may have developed governance systems, trade networks, shared knowledge, and cultural institutions. They may have persisted for centuries or millennia. What they may not have had is long-term survival under changing planetary conditions. The problem then is not whether intelligence existed. It did. The problem is whether survival allowed intelligence to compound. Earth does not reward long-term accumulation consistently. It rewards adaptation to current conditions. When conditions change faster than systems can adapt, collapse follows regardless of intelligence. This reframes the question of earlier civilizations. Instead of asking why we see no obvious evidence of advanced societies deep in the past, a better question might be why we expect to see such evidence at all. Given the instability of past climates, repeated ice ages, shifting coastlines, and ecological upheavals, sustained complexity would have been the exception, not the rule. Intelligence might have flared repeatedly, only to be forced back into simpler modes of survival. There is also a human tendency to underestimate how much effort is required to maintain knowledge. Knowledge is not static. It must be practiced, tested, updated, taught. Without institutions that persist across generations, knowledge degrades. Misunderstandings accumulate. Precision is lost. Oral traditions can preserve information remarkably well, but they are optimized for relevance, not completeness. What does not serve immediate needs is dropped. Over time, this shapes culture toward resilience rather than accumulation. A society focused on survival may intentionally shed complexity. Another assumption worth examining is that technological development follows a single path. We often imagine a progression from stone to metal to industry, but technology is not a ladder, it is a branching tree. Different environments and priorities produce different solutions. A society may develop sophisticated techniques that leave little physical trace, knowledge of materials, mastery of navigation, ecological engineering, social systems that optimize cooperation and conflict resolution. None of these require heavy infrastructure. If such a society faced repeated disruptions, its intelligence might never manifest as durable artifacts. It would exist primarily in practices and relationships, which disappear quickly once those practices stop. This creates a mismatch between intelligence and archaeology. Archaeology is good at finding objects. It is poor at finding systems. The problem of survival, then, is not just biological. It is informational. It is cultural. It is environmental. Intelligence can solve immediate problems, but it cannot override planetary dynamics indefinitely. Even today, with unprecedented technological capability, civilization remains vulnerable. Climate change, resource depletion, and ecological strain threaten the stability that complexity depends on. Our intelligence has allowed us to recognize these threats, but recognition does not guarantee resolution. This should temper assumptions about the past. If modern civilization, with global communication, advanced science, and vast energy reserves, struggles to ensure its own continuity, it is unreasonable to assume that earlier societies, however intelligent, would have fared better under harsher and more variable conditions. The silence in the deep past does not imply absence of intelligence. It implies that survival conditions did not favour long-lasting accumulation. This perspective also shifts how we interpret innovation. Rather than seeing the emergence of civilization as a sudden leap in intelligence, it can be seen as a convergence of favourable conditions, stable climate, abundant resources, relative environmental predictability, sufficient population density. When those conditions align, intelligence expresses itself in visible, lasting ways. When they do not, intelligence expresses itself quietly, locally, and transiently. When we think about tools, we tend to picture objects that last. Stone blades, metal implements, things you can hold, label, catalogue, and place in a museum drawer. These are the tools that shape our understanding of the past because they are the ones that endure. They survive burial, weathering, and time well enough to be found again. Over thousands of years, they become the visible vocabulary of archaeology. But this creates a quiet misunderstanding. Most tools used by humans across most of our existence do not fossilize. They rot, dissolve, shatter, burn, or are eaten by the environment. They leave behind no clear outline of their former shape or function, and because of that, entire technological worlds can vanish without leaving behind anything recognizable as technology at all. This matters deeply when we ask whether complex societies could have existed before the ones we know. Wood is the most obvious example. It is abundant, versatile, and easy to shape. It can be carved, bent, split, layered, and joined. With sufficient knowledge, wood can form buildings, vehicles, machines, tools, containers, weapons, musical instruments, and structural systems of surprising sophistication. Entire civilizations have relied primarily on wood, and yet wood almost never survives deep time, unless it is preserved in extremely dry, frozen, or oxygen-poor conditions. Wood decomposes completely. Microorganisms break it down efficiently. Fungi digest it. Insects consume it. Water softens and fragments it. Fire destroys it quickly. Within a few centuries, most wooden objects vanish entirely. Within a few thousand years, even large wooden structures can leave no visible trace. A city built primarily of wood does not leave ruins, it leaves soil. The same is true for plant fibers. Rope, cloth, baskets, nets, mats, sails, and clothing all depend on fibers that decay rapidly. Yet these items are essential tools. Nets enable large-scale fishing. Rope enables construction and transport. Cloth enables climate adaptation. Without these technologies, complex societies struggle to function, and none of them fossilize under normal conditions. Leather and hides behave similarly. They are crucial materials for containers, footwear, armor, bindings, and structural components. They preserve briefly under rare circumstances, but over deep time they vanish completely. Now consider tools made of bone, shell, and antler. These survive better than organic fibers, but they are still fragile. Acidic soils dissolve them, water erodes them, biological activity breaks them down. Their survival is uneven and biased towards specific environments. What remains visible to us is not a fair sample of what was used. It is a small, distorted subset. Even stone tools, the most iconic markers of early human technology, represent only a fraction of technological activity. Stone is used where it is useful and available, but it is often paired with organic components that do not survive. A stone blade might be hafted to a wooden handle with plant resin and fibre bindings. The stone survives. Everything else disappears. When we find the blade alone, we see a simple object. We do not see the composite tool it once belonged to. This pattern repeats endlessly. Spears lose their shafts. Axes lose their handles. Complex devices collapse into isolated fragments. Over time, those fragments are interpreted as standalone tools, rather than components of more elaborate systems. The absence of surviving complexity is mistaken for absence of complexity itself. Now consider tools that are not objects at all. Techniques, procedures, skills, knowledge systems, knowing how to read weather patterns, how to track animals, how to manage ecosystems, how to preserve food, how to navigate without landmarks, how to coordinate large groups socially. These are tools as real as any blade or hammer. They shape survival and organization. They enable societies to function at scale. None of them fossilize. A society could possess advanced ecological engineering knowledge, shaping landscapes subtly to increase productivity, without building monumental structures. It could manage water flows, plant distributions, and animal populations in ways that leave only faint, ambiguous traces. To future observers, such landscapes might appear natural. Fire management is a good example. Controlled burning can shape entire ecosystems, increasing biodiversity and productivity. It requires planning, timing, and collective action. Over long periods, it can transform landscapes profoundly. Yet the tools involved are knowledge and coordination, not durable objects. Another example is navigation. Long-distance travel by sea or land requires sophisticated understanding of geography, astronomy, currents, winds, and timing. It can support trade networks, cultural exchange, and political organisation across vast regions. The tools of navigation are memory, observation, and tradition. The physical components, boats, sails, ropes, are organic. They disappear quickly. Without written records or preserved vessels, navigation capability leaves almost no trace. If such a society collapsed, its reach would vanish with it. There is also the issue of scale. Tools that do not fossilise are often the ones that enable scaling up. Agriculture relies heavily on organic tools. Ploughs, handles, baskets, storage containers, irrigation components. The visible traces we find, such as grinding stones or sickle blades, are just the durable edges of a much larger system. Remove the organic components, and the system becomes difficult to reconstruct. Now imagine a society that intentionally favoured materials that blended back into the environment. Perhaps for practical reasons, perhaps for cultural ones. Such a society would be nearly invisible archaeologically, even if it were complex. This is not hypothetical. Many known societies built with earth, wood, and fibre. Their absence from the deep record is not because they were insignificant, but because their material choices were incompatible with long-term preservation. The fossil record does not reward sustainability. It rewards excess stone, fired clay, and metal. This creates a bias. Societies that leave heavy, durable waste appear more prominent in history. Societies that integrate smoothly with their environments appear primitive or absent. The same bias applies to technology trajectories. We assume technological advancement must lead toward metallurgy, large-scale construction, and eventually industrialization. But this is a path shaped by specific resource availability and historical circumstances. Alternative technological paths are possible, paths that prioritize renewability, flexibility, and low-impact materials. Such paths may reach high levels of efficiency and organization without producing long-lasting debris. From the perspective of deep time, these paths vanish. There is also the problem of reuse. Organic tools are reused until they fail completely. They are repaired, repurposed, and eventually discarded in ways that leave no concentrated deposits. Stone tools, by contrast, often accumulate because they are harder to destroy. This leads to an archaeological illusion of stone dominance. Even today, many of our most critical tools would leave little trace without active preservation. Software does not fossilize. Algorithms do not fossilize. Electrical signals do not fossilize. Data stored magnetically or electronically degrades quickly without maintenance. Future investigators might find circuit boards, but not the systems that made them meaningful. If a technologically capable society relied heavily on ephemeral tools, its technological footprint would be faint even after a short time. After tens of thousands of years, it would be nearly impossible to identify. Another subtlety is that tools are often mistaken for intelligence itself. We see advanced tools and infer advanced minds. We see simple tools and infer simplicity. But tools reflect constraints as much as capability. A group living in an unstable environment may choose tools that are quick to make, easy to replace, and easy to carry. These tools may look crude when isolated, but they may be part of a highly optimized survival strategy. Conversely, elaborate tools may reflect stability rather than intelligence. The idea that civilization must announce itself through durable tools is rooted in our own experience. We live in a world that produces massive amounts of long-lasting material waste. That is not a universal feature of intelligence. It is a feature of a specific historical moment. When we look deep into the past and see only stone and bone, we're not seeing the full toolkit. We are seeing the residue of preservation bias. This does not mean that earlier societies had hidden advanced technologies identical to ours. It means that our criteria for recognizing complexity are narrow. If civilization occurred in forms that relied heavily on non-fossilizing tools, its disappearance would be expected. Not mysterious, not dramatic, just thorough. As time passes, the line between presence and absence blurs. Organic tools disappear first, then composites, then context. What remains are isolated artifacts that tell incomplete stories. Archaeology is excellent at working with what remains. It is not designed to detect what is fully dissolved. This places limits on certainty. When we say we see no evidence of certain kinds of past societies, what we are really saying is that we see no durable remains that fit our expectations. That distinction matters. Tools are not just objects, they are choices shaped by environment, culture, and survival pressures. Many of the most important ones leave nothing behind, and in a deep time world, what leaves nothing behind is very easy to forget. When people look at timelines of human history, the eye is naturally drawn to what is filled in. Dates, cultures, transitions neatly labelled. Stone Age giving way to Bronze Age, then Iron Age, then onward into more familiar territory. The empty spaces between those labels rarely receive the same attention. They are treated as pauses, waiting rooms between meaningful developments, stretches where nothing much happened. Those empty spaces are stranger than they look. The human story, when examined closely, is not a continuous line. It is punctuated by gaps, long ones, uneven ones, periods where evidence thins dramatically, where cultural signals fade, and where explanations become cautious and vague. These gaps are often smoothed over in summaries, but they persist stubbornly in the underlying data. The usual explanation for these gaps is simple. People were fewer. Technology was simpler. Life was repetitive. There was less to leave behind. On the surface, that explanation feels reasonable. But when held up against what we know about human capability, environmental change, and time itself, it begins to feel incomplete. One of the first things to notice is how unevenly evidence is distributed. Some periods are rich with artifacts, structures, and clear signs of organization. Others, sometimes immediately adjacent in time, appear almost empty. This pattern repeats across regions. A burst of activity, then silence. A sudden appearance of complex behavior, then long stretches where it seems to stall or vanish. If human development were purely linear, driven steadily by intelligence and innovation, this pattern would be difficult to explain. Instead, what we see looks more like interruption. Take population estimates. Genetic evidence suggests that human populations have passed through severe bottlenecks multiple times. Numbers dropped dramatically, sometimes to surprisingly low levels. These were not minor fluctuations. They were near extinction events in some regions. After each bottleneck, populations expanded again, carrying only a subset of previous diversity, both genetic and cultural. Each bottleneck is a reset. When populations shrink, knowledge shrinks with them, not because people forget everything, but because complex systems require scale. Skills that depend on specialization disappear first. Practices that require coordination across large groups become impossible. What survives is what fits into small mobile communities. This creates a strange illusion in the archaeological record. A culture may appear to simplify over time, even though the people involved are just as capable as before. The gap is not cognitive, it is demographic. Another source of gaps lies in migration. Humans did not stay put. They moved repeatedly, often over vast distances, following changing climates, resources and pressures. Migration disrupts continuity. Settlements are abandoned. Landscapes are left behind. New environments demand new adaptations. In the record, this can look like disappearance. A culture vanishes from one place, and another appears elsewhere with different material signatures. Without clear links, the connection between them is lost. Language compounds this problem. As groups separate, languages diverge rapidly. Within a few thousand years, mutual intelligibility can disappear entirely. along with language, stories, and technical knowledge shift, shared memory fractures. What was once a single cultural trajectory becomes many disconnected ones. Environmental change deepens these gaps. Periods of relative stability allow accumulation. Periods of rapid change force simplification. The transition between these modes does not leave neat markers. Instead, it leaves absences. Consider the end of the last ice age. As glaciers retreated, climates shifted quickly. Sea levels rose, ecosystems reorganized. Humans adapted, but adaptation does not happen uniformly. Some groups thrived, others declined or disappeared. Settlements were abandoned. New ones formed in unfamiliar places. The archaeological record reflects this upheaval unevenly. Some regions show dense evidence, others show sudden silence. Silence does not mean emptiness, it means disruption. Another contributor to the strange gaps is the nature of archaeological visibility. Archaeology relies on discovery. Discovery depends on exposure. Exposure depends on erosion, construction, or targeted excavation. Many regions remain unexplored simply because they are inaccessible, protected, or politically unstable. Large portions of the world's land surface have never been systematically surveyed. Even less of the seafloor has been examined. Entire chapters of human history may lie hidden, not erased, but unobserved. Yet even in well-studied regions, gaps persist. There are periods where tools appear more refined than expected, then disappear. There are sudden leaps in technique that lack obvious precursors. There are long intervals where technological styles remain static, followed by rapid change. These patterns are often explained as innovation bursts. Someone figures something out, it spreads, then plateaus. That explanation may be partly true, but it does not address why long stretches of time appear to leave so little behind. One possibility is that we are mistaking continuity for absence. If tools and practices change slowly, or were primarily organic, their traces may blend together indistinguishably. 1,000 years of subtle variation might collapse into a single style in the record. Another possibility is that earlier complexity existed in forms we do not recognize easily. Social organization, trade networks, governance structures, and knowledge systems can exist without leaving durable material signatures. Their presence would not fill archaeological gaps with artifacts, but with influence, which is harder to detect. Trade is a good example. Long-distance exchange can connect distant regions, spread ideas, and support specialization. But unless trade goods are distinctive and preserved, the network itself remains invisible. When trade collapses, the gap appears abrupt. There is also the issue of expectation. Archaeologists, like all scientists, operate within frameworks shaped by previous findings. These frameworks guide interpretation. When evidence does not fit, it may be set aside as anomalous until more context emerges. Over time, this can reinforce certain narratives and obscure others. These strange gaps in the human story are not just about missing objects, they're about missing transitions. We often know what came before and what came after, but not how one turned into the other. The mechanisms are lost. How did mobile groups become sedentary in specific places? Why did some regions urbanize while others did not? Why did certain technologies spread rapidly in some periods, but not others? These questions often sit inside gaps where evidence is thin. It is tempting to fill those gaps with assumptions. Simpler lifestyle, slower progress, limited capability. But those assumptions are not strongly supported by what we know about human cognition. Humans have always been inventive. What changes is whether invention can accumulate. Another subtle factor is time compression in storytelling. When thousands of years are summarized in a paragraph, gaps are flattened. Gradual processes appear sudden. Disappearances seem complete. Continuities become invisible. This storytelling convenience feeds certainty. But when the data is examined at finer resolution, uncertainty dominates. Timelines blur. boundaries soften, categories overlap. What once looked like a clean transition becomes a messy, extended process. The strange gaps also challenge the idea that civilization once achieved must spread everywhere. History does not support that. Even within the last few thousand years, complex societies have coexisted with simpler ones. Urban centres existed alongside mobile groups. Trade networks touched some regions and bypassed others. There is no rule that complexity must be universal. This matters because it means that the absence of civilization in one region during a given period does not preclude its presence elsewhere. Gaps in one area may coincide with activity in another. Without global synchronization, the record appears uneven. Add to this the effects of reuse and overbuilding. Later societies often build directly atop earlier ones. They quarry old structures. They disturb earlier layers. This destroys context. In some cases, entire earlier settlements are erased not by natural forces, but by later human activity. The result is a palimpsest where earlier writing is scraped away to make room for new. Even modern development continues this process. Roads, cities, and agriculture destroy archaeological layers constantly. The deeper past has been overwritten many times. The strange gaps are therefore not empty by accident. They are the product of overlapping processes that favour erasure over preservation. When we step back and consider all of this together, a different picture emerges. The human story is not a steady ascent interrupted by brief pauses. It is a patchwork of advances and retreats, expansions and contractions, memories built and memories lost. The gaps are not anomalies. They are expected outcomes of living on a dynamic planet. This does not mean that every gap hides a lost civilization. It means that certainty about absence should be held lightly. The record we have is incomplete in predictable ways. It favours certain materials, environments, and outcomes. Recognising this does not weaken our understanding of the past. It strengthens it by acknowledging its limits. The story does not move in a straight line. It jumps, stalls, fractures, and resumes. And in those strange gaps, the most important thing to remember is not what we cannot see, but how easily seeing itself can fail. History often gives the impression of choice. Decisions made, paths taken, empires rising because someone planned well, falling because someone failed. This perspective makes human agency feel central, as if history bends primarily in response to intention. But over deep time, some of the most decisive moments arrive without asking permission from anyone involved. Catastrophes do not negotiate with civilizations. They do not consider preparedness, intelligence, or cultural achievement. They arrive according to physics, geology, and climate, and when they do, they redraw the map of what survives and what does not. When we talk about catastrophes, it is easy to imagine single dramatic moments. An impact, a massive eruption, a sudden flood. While those events do happen, and they matter, the most effective catastrophes are often not instantaneous. They unfold over years, decades, or centuries, slowly dismantling the systems that support complex societies. From the perspective of survival, a catastrophe does not need to kill everyone. It only needs to break continuity. One of the most underestimated forms of catastrophe is abrupt climate shift. Earth's climate has changed rapidly many times in the recent geological past. Temperature swings of several degrees over a few decades may not sound dramatic on paper, but for ecosystems and human societies, they are devastating. Rainfall patterns shift, growing seasons shorten or fail, water sources dry up or become unpredictable. Agriculture is especially vulnerable to this kind of change. Crops depend on narrow climate windows. A few decades of instability can undermine food production enough to trigger famine, migration, and conflict. Once agricultural systems collapse, cities struggle to survive, trade networks break, specialization becomes impossible. What follows is not a dramatic end, but a thinning. Populations decline. Settlements are abandoned gradually. knowledge disperses unevenly. By the time the climate stabilizes again, the society that once existed may no longer be recognizable. Volcanic activity is another powerful editor of history. Large eruptions inject ash and aerosols into the atmosphere, cooling the planet temporarily and disrupting weather patterns globally. Crops fail far from the eruption site. Livestock die. Food shortages ripple outward. In regions closer to the eruption, the effects are more direct. Ash buries settlements. Lava reshapes landscapes. Rivers are blocked or redirected. Entire valleys become uninhabitable. Even when populations survive, they may be forced to relocate permanently. The archaeological record often preserves these moments well. Ash layers form clear boundaries. Settlements frozen in time attract attention. But what is preserved is the moment of destruction, not the long-term consequences. The slow unravelling that follows is hard to see. Flooding is another quiet rewriter. Rising seas, glacial outburst floods, and massive river floods can erase entire regions of habitation. Unlike fire or impact, flooding often leaves little dramatic debris. Structures collapse and are carried away. Sediments settle. Over time, the area appears naturally shaped. If flooding is repeated or sustained, memory dissolves. People move on, the land becomes something else. Impact events, while rarer, are among the most disruptive catastrophes Earth experiences. Large impacts can alter climate globally, trigger wildfires, acid rain, and long-term cooling. Even smaller impacts can cause regional devastation and long-lasting ecological effects. The key point is not how often these events occur, but that they do occur. Over hundreds of thousands of years, the probability that civilizations will encounter multiple catastrophic disruptions approaches certainty. Another category of catastrophe is biological. Disease outbreaks can reshape societies dramatically. Before modern medicine, pathogens could sweep through populations repeatedly. Dense settlements became liabilities. Trade routes spread infection faster than information. Pandemics reduce population size, disrupt social structures, and break transmission of knowledge. They can trigger fear-driven behaviour, social fragmentation, and abandonment of complex systems. Even if societies recover numerically, cultural continuity may not. Disease does not leave clear archaeological markers. Skeletons rarely record cause of death definitively. Mass graves may exist, but they do not tell the full story of social collapse that follows. The record shows gaps, not explanations. Fire, too, operates at multiple scales. Local fires destroy settlements. Regional fire regimes reshape ecosystems. Global fire episodes, sometimes triggered by climate change or impacts, can blanket continents in smoke, alter atmospheric chemistry, and disrupt food chains. Fire leaves charcoal, but charcoal does not narrate consequences. Earthquakes are another force that rarely receives enough attention in long-term history. Major seismic events can destroy cities instantly, alter landscapes, redirect rivers, and make entire regions unsafe. In tectonically active zones, earthquakes recur. Rebuilding becomes risky. Over time, populations may abandon areas entirely. The absence of later occupation can look like a cultural choice, when it is really a geological one. What all these catastrophes share is indifference. They do not target civilizations because they are advanced. They target regions because of where they are and how the planet behaves. A society can do everything right and still be erased. This challenges the idea that progress guarantees persistence. One of the most important consequences of catastrophe is fragmentation. Survivors scatter, groups separate, communication breaks down, shared systems dissolve into local practices. Over time, what was once a unified civilization becomes multiple unrelated cultures. In the archaeological record, this fragmentation appears as disappearance. A style ends, a settlement network vanishes, a technology is no longer found. What is not visible is the continuity carried in people who moved elsewhere and adapted. Catastrophes also compress time. Long developments end abruptly. Gradual processes stop mid-course. Future observers see sharp boundaries and assume sudden collapse, when the reality may have been prolonged stress followed by tipping points. Another overlooked effect is psychological. Catastrophe reshapes priorities. Long-term planning loses relevance when survival is uncertain. Investment in infrastructure feels risky. Cultural focus shifts toward resilience and caution. These shifts affect what societies build. They may avoid large structures. They may favour mobility. They may emphasise redundancy over growth. To future observers, such societies appear simpler, even if their knowledge is deep. Repeated catastrophe trains cultures not to overcommit to permanence. From this perspective, the absence of long-lasting civilizations in deep time is not surprising. It may reflect wisdom rather than failure. Societies that endured repeated disruption may have learned not to build in ways that invite catastrophic loss. Another subtlety is that catastrophes do not affect all regions equally. While one area suffers devastation, another may remain stable. Civilization could shift geographically rather than disappear entirely. Over time, this creates a patchwork record where activity appears and disappears in different places. Without global synchronization, this looks like randomness. Catastrophes also interact. A volcanic eruption triggers climate cooling, which leads to crop failure, which triggers migration, which spreads disease, which weakens societies further. By the time collapse is visible, the initiating event may be long past. The record shows outcomes, not chains of cause. This makes interpretation difficult. It also invites oversimplification. We label periods as dark ages, declines, or regressions without fully appreciating the complexity of pressures involved. When we consider the possibility of earlier civilizations, catastrophes become central, not as dramatic endpoints, but as recurring filters that favour simplicity over complexity. Civilization is not just something that emerges, it is something that must be protected continuously against forces that do not care about it. Even now, with global technology, humanity remains vulnerable to catastrophic disruption. Our systems are complex and interconnected, which makes them efficient but brittle. Supply chains stretch globally. Energy systems are centralized. Communication depends on infrastructure. A sufficiently large disruption would not need to destroy everything to cause lasting regression. It would only need to interrupt continuity long enough for complexity to unravel. Looking backward, it becomes easier to imagine how earlier societies could have risen and fallen without leaving clear signatures. Catastrophes would not leave neat endings. They would leave thinning traces, abandoned landscapes, and scattered survivors. The planet does not keep score. It does not mark how many times intelligence has organized itself into complex systems. It simply applies pressure repeatedly. History, then, is not written solely by those who plan. It is edited relentlessly by those who do not ask permission. Catastrophes rewrite history quietly and repeatedly, and in the space they leave behind, certainty fades, replaced by questions that refuse to disappear entirely. Long before history was written down, before dates were fixed and events were ordered into timelines, humans remembered the past in a different way. They told stories, not stories meant to document facts precisely, but stories meant to carry meaning forward when everything else was uncertain. These stories survived not because they were accurate in every detail, but because they were memorable, adaptable, and useful to the people who told them. Myths are often treated as the opposite of history. Where history is expected to be factual, myths are assumed to be imaginative, symbolic, or exaggerated. That distinction feels clean, but it is also misleading. Myths are not random inventions. They are structured responses to experience, shaped by memory, environment, and repeated retelling across generations that did not have the luxury of written archives. When the material record fails, stories take over. This makes myths one of the few possible carriers of memory across deep disruptions. But they do not carry memory intact. They carry it distorted, compressed, and reframed to fit new circumstances. What survives is not a photograph of the past, but an echo. Across cultures separated by vast distances and long spans of time, certain mythic themes repeat with striking consistency. Floods that destroy earlier worlds, fires that cleanse and reset creation, ages of humanity that end in catastrophe, lost golden eras when people lived differently, closer to the gods or the land before something went wrong. These patterns are often explained as symbolic reflections of human psychology, and they are that. But symbolism does not exclude origin. Repeated patterns suggest repeated experiences. A flood myth does not require a single global flood to exist. It requires repeated encounters with devastating flooding, experienced as world-ending by the societies affected. For coastal or riverine populations, sea level rise, storm surges, or glacial meltwater floods could erase entire regions of habitation within a generation. To survivors, the world they knew was gone. What replaced it was unfamiliar land or water. That experience does not need to be remembered with precise dates or measurements to be passed on. It needs only to be remembered as a warning, an explanation, or a story of loss. Over time, such stories evolve. They absorb moral lessons. They are tied to cosmology. They become creation myths rather than historical accounts. But their persistence suggests they are anchored in something more than imagination alone. The same is true of myths about fire. Stories of great fires that reshape the land appear in many traditions. Some are clearly symbolic. Others may echo periods of widespread burning caused by climate shifts, volcanic activity, or impact events. Large-scale fire episodes leave traces in charcoal layers, but the human experience of them is carried forward through narrative. Then there are myths of lost knowledge, stories of ancestors who possessed great understanding, built remarkable things, or lived in harmony with forces now misunderstood. These stories often end with decline. Knowledge is lost. Humanity becomes smaller, weaker, or more fragmented. The cause is sometimes hubris, sometimes disaster, sometimes simply the passing of an age. From a modern perspective, these stories are often dismissed as nostalgia or moral allegory. But from the perspective of deep time, they may reflect something more literal, not specific technologies, but the repeated experience of losing continuity. When societies collapse or fragment, later generations are often aware that something was lost, even if they cannot describe it precisely. They inherit tools they do not fully understand. They encounter ruins they cannot explain. They hear fragments of stories whose original context is gone. Over time, those fragments become mythic. Myths are also shaped by survival bias. Only certain kinds of stories persist. Those that are emotionally compelling, adaptable, and relevant to new conditions survive retelling. Those that depend on precise technical detail do not. This filters memory aggressively. A story about a great city lost to the sea may survive. A detailed description of its governance structure will not. This filtering does not mean myths are useless as historical signals. It means they must be interpreted carefully. Not as records of events, but as indicators of repeated experiences. Another important aspect of myth is that it does not belong to one moment. It is layered. Each retelling adds something. Each generation reshapes it slightly. Over centuries, myths become composites of many events, many places, and many losses. This makes them frustrating for historians seeking clarity. It also makes them resilient. If civilizations rose and fell multiple times, myths would not preserve each instance separately. They would blend them together. The result would be stories that feel timeless, placeless, and universal. That universality is often taken as proof that myths are purely symbolic, but it may also be evidence that similar processes occurred repeatedly across different times and places. Consider stories of earlier ages of humanity. Many traditions describe successive worlds or eras, each ending in destruction. The details differ, but the structure is similar. Humanity is created, thrives, fails, and is replaced or renewed. The cycle repeats. From a modern standpoint, this looks like metaphor. From a deep time standpoint, it could reflect an intuitive understanding that human existence is not continuous or linear, that worlds end, that continuity breaks, that what exists now is not the first attempt. Myths also preserve emotional truth, fear of instability, respect for forces beyond control, awareness that survival is conditional. These themes align closely with what we know about Earth's history. Another feature of myth worth noting is its relationship to place. Many myths are tied to specific landscapes, mountains that once were islands, plains that were once seas, forests that hide ancient dwellings. These associations sometimes correspond to real geological changes. As sea levels rose, stories may have shifted inland. As rivers changed course, stories followed them. Over time, the original geography was forgotten, but the narrative structure remained. This process does not preserve maps. It preserves meaning. Skepticism toward myth as historical evidence is justified. Myths are not data sets. They cannot be verified directly. They are shaped by culture, power, and imagination. But dismissing them entirely misses their value as signals of memory under pressure. When written records fail, when material traces disappear, stories are the last refuge of continuity. It is also important to recognize that myths are not created in isolation. They are reinforced through ritual, repetition, and social importance. This gives them staying power that outlasts political systems and material cultures. A story told around a fire can survive the loss of a city. A ritual can persist long after its original purpose is forgotten. This makes myth a plausible carrier of deep-time memory, albeit in altered form. Another subtle point is that myths often emphasize reset rather than progress. They describe endings more vividly than beginnings. This focus aligns with lived experience in unstable environments. People remember catastrophes more strongly than slow growth. Loss is more narratively powerful than accumulation. If civilizations rose and fell repeatedly, memory would cluster around endings. This does not mean myths encode detailed knowledge of earlier civilizations. It means they may encode awareness that the world has been very different before, and that those differences ended abruptly. Modern societies often underestimate how much is lost during collapse. We imagine recovery as a return to normal, but collapse reshapes identity. It reframes history. It redefines what is possible. Myths emerge from that reframing. There is also the question of intentional forgetting. After catastrophe, some societies may deliberately distance themselves from the past. Ruins become taboo. Old knowledge is associated with danger. Stories are reshaped to warn rather than explain. This further distorts memory, but it preserves the sense that something once existed and was lost. From this perspective, myths are not failed histories. They are adaptive histories. They prioritize survival over accuracy. They warn, instruct, and comfort rather than document. When considering the possibility of earlier civilizations, myths do not provide proof. They provide context. They suggest that human cultures have long understood the world as cyclical, fragile, and prone to reset. That understanding did not come from abstract theory. It came from lived experience. The absence of explicit references to advanced technology in myths is sometimes cited as evidence that no such civilizations existed. But myths are not interested in technology. They are interested in relationships between humans and nature, between actions and consequences, between continuity and loss. Technology, if remembered at all, is remembered as magic or divine power. This is not because people were confused, it is because technical explanation requires continuity of practice. Once practice is lost, only the effect remains meaningful. A machine becomes a miracle, a system becomes a story. This process is visible even in recent history. Technologies that are no longer understood are mythologized quickly. Abandoned infrastructure becomes mysterious. Past capabilities are exaggerated or misunderstood. Scale that process up across millennia, and the transformation is complete. Myths as faded echoes do not tell us what earlier worlds looked like. They tell us that earlier worlds ended. They tell us that people have lived with the awareness of impermanence for a very long time, that the idea of being the first or the last has never been stable, that humanity has always suspected it is living in the aftermath of something. This does not require belief in lost advanced civilizations. It requires recognition that memory adapts to loss, and that storytelling is one of the few tools resilient enough to survive repeated erasure. As we move forward, the focus will shift again, from stories to silence, from echoes to absence. Not all memory survives as myth. Much of it disappears entirely. And in that disappearance, we are left with a question that grows harder the longer it is considered. Could technology itself rise and vanish so quietly that even stories fail to remember it? The image most people carry of technological rise is loud. Smokestacks, expanding cities, machines multiplying, roads spreading outward like veins. Technology in this picture announces itself. It leaves scars. It demands attention from the landscape and from history alike. When we look around today, this feels obvious. Our technology is noisy, material heavy, and difficult to ignore. But that image is shaped by a very specific moment in time. Technology does not have to rise loudly, and it does not have to vanish in flames. Technology is not a single thing. It is a relationship between knowledge, materials, energy, and goals. Change any one of those elements, and the outward expression of technology changes as well. What we recognize as technological progress is deeply tied to the resources we exploit, the scale at which we operate, and the risks we are willing or forced to accept. If we step away from the assumption that technology must always trend toward visible expansion, a quieter possibility emerges. A society does not need smokestacks to be technologically sophisticated. It does not need sprawling infrastructure to be organized. It does not need permanent monuments to be capable. Under certain conditions, especially unstable ones, the most successful technologies are those that minimize footprint rather than maximize output. Quiet technology prioritizes survival, efficiency, adaptability, and reversibility. Imagine a society that has learned through repeated disruption that permanence is dangerous, that large centralized systems fail catastrophically when conditions change, that dependency on narrow resource chains invites collapse. Over time, such a society might intentionally favor technologies that are modular, local, and easily dismantled. These technologies would not look impressive to a distant future. They would look temporary. Energy might come from sources that leave no trace once abandoned. Wind, water, biomass, passive thermal systems. Structures might be designed to degrade safely back into the environment rather than resist it. Tools might be repaired endlessly rather than replaced. Waste might be minimal, reused, or organic. From the inside, this would not feel like technological restraint. It would feel like wisdom. From the outside, thousands of years later, it would look like absence. Modern thinking often equates technological advancement with increasing complexity and scale. But complexity can also be internalized. Systems can become sophisticated without becoming physically massive. Knowledge can deepen without producing heavier artifacts. Consider how much of modern capability is invisible. Software governs systems more than hardware does. Algorithms matter more than machinery in many domains. Coordination, timing, and information flow determine efficiency more than raw power. Remove electricity and this world collapses instantly. Leave behind the physical remnants, and they tell almost none of the story. Now imagine a society that reached advanced levels of coordination and knowledge without crossing into heavy industrialization, perhaps because the environmental cost was too high, perhaps because energy density was limited, perhaps because catastrophe had taught restraint. Such a society might develop impressive capabilities in navigation, agriculture, medicine, astronomy, ecology, and social organization, all while leaving behind little that fossilizes. Navigation is a powerful example. A society capable of long-distance travel across oceans or continents can connect distant regions, share ideas, and maintain trade networks without building permanent infrastructure. The ships are organic, the sails are fibre, the knowledge is mental. Once the ships rot and the sailors die, nothing remains. Astronomy is another example. Tracking celestial cycles does not require observatories built of stone. It requires observation, memory, and transmission. Knowledge can be encoded in stories, rituals, or calendars tied to landscape features that later erode or are renamed. Medicine, too, can be highly advanced without leaving tools behind. Herbal knowledge, surgical techniques using organic instruments, understanding of hygiene and disease prevention. Without written records or preserved instruments, this knowledge vanishes completely when transmission breaks. Agriculture itself does not require permanent structures, terracing, soil management, crop rotation, seed selection. These practices shape landscapes subtly. Once abandoned, erosion and vegetation reclaim them. Over time, the land appears natural again. The question is not whether such technologies are possible. We know they are. The question is whether they could support civilization-level organization. The answer depends on how civilization is defined. If civilization means centralized states, massive cities, rigid hierarchies, and monumental architecture, then quiet technology struggles to support that form. But if civilization is defined as sustained large-scale cooperation, shared knowledge systems, cultural continuity, and organized resource management, then quiet technology is sufficient, and possibly preferable under unstable conditions. Quiet technology also vanishes quietly. When such a society collapses, there is no dramatic endpoint, no layers of ash, no toppled skyscrapers. There is dispersal, knowledge fragments, practices become local, tools revert to simpler forms not because knowledge is lost instantly, but because complexity is no longer useful. Within a few generations, the outward signs of advanced capability disappear. What remains is not ruin, but normalcy. Future observers would see a population using simple tools and assume they had always done so. This process happens even in recorded history. Techniques are lost, skills disappear. Later generations may not even realize what their ancestors were capable of. The past becomes flatter than it was. Now consider this process repeated multiple times across deep time, each cycle separated by catastrophe, climate shift, or migration. Each rise quiet, each fall quieter still. The absence of obvious technological layers begins to make sense. Another reason technology might rise quietly is risk management. Heavy infrastructure ties a society to specific locations. It makes retreat difficult. In a world prone to flooding, ice advance, drought, or fire, being able to move quickly can mean survival. Mobility is a technology. A society optimized for mobility invests less in fixed structures and more in transport, coordination, and adaptability. The technological emphasis shifts inward. Knowledge becomes portable. Social bonds replace walls. Redundancy replaces centralization. Such a society may achieve impressive feats that leave no durable trace. There is also the possibility that earlier technological paths diverge significantly from ours. We often assume that metallurgy and industrialization are inevitable milestones, but these are contingent on resource distribution and cultural priorities. A society in a region with limited accessible metal ores may develop alternatives: composite materials, ceramics, advanced woodworking, chemical processing using organic compounds. These paths can lead to high efficiency without heavy metal use. Even today, Some of the most advanced materials are polymers and composites. Without fossil fuel infrastructure, such materials would degrade quickly after abandonment. Technology does not have to follow the same ladder everywhere. Another factor to consider is scale limitation. Quiet technologies may scale regionally rather than globally. They may support dense populations in favourable areas without spreading outward aggressively. When conditions change, the contraction is equally local. This creates a patchy archaeological footprint. Activity appears in some regions and not others. Over time, these patches vanish independently. From a future perspective, this looks like sporadic development rather than repeated cycles. One might argue that even quiet technology would leave some unmistakable trace, some chemical signature, some anomaly, and it might. But interpretation depends on recognition. An unusual concentration of elements might be dismissed as natural. Altered soil profiles might be attributed to erosion. Subtle landscape engineering might be interpreted as geology. Without context, technology dissolves into ambiguity. The farther back in time one looks, the more context disappears. It is also important to consider intent. Not all societies aim to dominate their environments. Some aim to fit within them. For such societies, success is measured by longevity, not expansion, by balance, not growth. In these cases, technological advancement may actively avoid leaving marks that attract attention or create vulnerability. Modern civilization leaves enormous scars. That does not mean all civilizations would choose to do so. Quiet rise is not primitive, it is strategic. Quiet disappearance is not failure, it is absorption. If such a society existed, its end would not be dramatic. It would not be remembered clearly even by its descendants. Knowledge would thin, practices would simplify, stories might hint at a past that feels richer, but details would be lost. Eventually, even the hint would fade. This possibility is uncomfortable because it undermines a core belief, the belief that progress must be visible. That advancement leaves a trail we can follow backward confidently. That absence means non-existence. But deep time is not kind to confidence. Technology is a process, not an object. When the process stops, the object degrades. When knowledge transmission breaks, the technology effectively ceases to exist, even if remnants remain. This is true today. Remove training, supply chains, and maintenance, and modern technology becomes inert almost instantly. Quiet technology is even more fragile in this sense. Its existence depends almost entirely on continuous practice. Once practice ends, it leaves almost nothing behind. This does not mean that technology has risen and vanished many times. It means that the absence of evidence is not strong evidence against the possibility. The planet favours loud failures and durable excess. It forgets restraint efficiently. Could technology rise quietly? Yes. Could it vanish quietly too? On a planet this restless, that may be the most natural outcome of all. When people imagine Earth as a keeper of history, they often picture layers neatly stacked, one era resting politely atop the next, waiting to be read like pages in a book. In reality, Earth does not preserve evenly, and it does not preserve fairly. It erases selectively, following rules dictated not by significance, but by physics, chemistry, biology, and motion. Understanding what disappears first is essential if we want to understand why so much of the deep human past feels incomplete. The planet does not erase randomly, it erases predictably. The first things to go are not the most fragile in human terms, but the most exposed. Anything on the surface is living on borrowed time. Wind, rain, sunlight, temperature changes, and biological activity begin dismantling exposed materials immediately. The moment maintenance stops, decay starts. This is true whether the object is a hut, a road, a machine, or a city. Organic materials are erased almost immediately on geological timescales. Wood cracks, rots, and is consumed. Plant fibres fray and dissolve. Leather stiffens, breaks, and vanishes. Even in relatively dry environments, organic materials rarely survive more than a few centuries unless they are sealed away from air and moisture. On a planet covered in microorganisms, organic matter is food, not history. This means that the tools, structures, and systems most closely tied to daily life are the first to disappear. Homes, storage containers, clothing, transportation devices, agricultural implements. The physical infrastructure that actually supports civilization fades long before anything monumental does. Earth erases daily life first. After organic materials go, composites follow. Objects made of multiple materials degrade unevenly. Bindings fail, components separate. What remains no longer resembles the original tool or structure. A composite device collapses into fragments that are difficult to interpret. Context is lost before material is fully gone. This is why archaeology often finds isolated components rather than complete systems. A blade without a handle, a foundation without walls, a channel without its associated mechanisms. Earth dismantles relationships faster than it dismantles substances. Next to go are lightly worked earth structures. Mud brick buildings erode quickly once abandoned. Adobe walls melt back into soil. Earthen terraces slump. Ditches fill in. Within a few hundred years, such features can become indistinguishable from natural formations unless preserved by unusual conditions. This matters because many societies relied heavily on earth construction. It was efficient, insulating, locally available, and adaptable. From a living perspective, these structures were substantial. From a deep time perspective, they are almost invisible. Stone survives longer, but not as long as intuition suggests. Stone fractures under thermal stress. Water infiltrates cracks and expands during freezing. Roots force their way in. Chemical weathering dissolves minerals. Over long periods, even large stone blocks break down into gravel and then sand. More importantly, stone structures rarely survive intact where they are built. They are reused, quarried, broken down deliberately by later populations. Stone is valuable. It does not sit idle when people are present. A city built of stone becomes a resource for the next one. Earth erases stone through people before it erases it through geology. Metal behaves in ways that often surprise people. Iron rusts aggressively. In many soils, iron objects can degrade completely within a few centuries. Copper and bronze corrode and fragment. Aluminum oxidizes rapidly. Buried metal interacts chemically with its surroundings, dispersing into oxides and salts. Given enough time, metal objects lose their shape entirely. What remains is a faint chemical anomaly, not a recognizable artifact. Without context, such anomalies are difficult to attribute to human activity rather than natural mineralization. Earth erases technology chemically as much as physically. Glass is often assumed to be durable, but it too degrades. It fractures easily. It weathers chemically, developing surface crusts that eventually flake away. Over thousands of years, glass objects can crumble into unrecognizable fragments, especially in wet environments. Concrete, a hallmark of modern civilization, is not immortal. It cracks, spalls, and erodes. Reinforcing steel rusts and expands, accelerating structural failure. Without maintenance, concrete structures degrade surprisingly quickly. Over tens of thousands of years, they would leave little more than rubble mixed into sediment. Plastics feel eternal because they outlast a human lifetime. In reality, they break down under ultraviolet light, mechanical stress, and chemical processes. They fragment into smaller pieces, then smaller still. Over deep time, even plastics disperse into background material, losing form and meaning. Earth erases novelty faster than permanence. Another category Earth erases quickly is order. Organized layouts vanish faster than individual objects. Roads blur into paths, then into irregular ground. Grid patterns dissolve as erosion and vegetation disrupt alignment. Canals fill in unevenly. planned landscapes revert to organic randomness. This is critical because civilization is defined as much by organization as by objects. Once organization is gone, recognizing intention becomes difficult. Earth does not preserve design, it preserves leftovers. There is also the matter of scale. Small objects can sometimes survive better than large systems. A single stone tool might endure, while an entire settlement disappears. This inversion distorts perception. We find tools and imagine isolated activity, when those tools may have belonged to dense, organised populations whose broader context has been erased. Earth preserves fragments, not frameworks. Time accelerates erasure through repetition. A structure does not need to be destroyed once. It needs to be neglected repeatedly. Each cycle of wet and dry, hot and cold, freeze and thaw weakens it. Each biological cycle adds pressure. Over thousands of years, small stresses accumulate into disappearance. This makes Earth especially good at erasing things that were not meant to last forever. Temporary shelters, seasonal settlements, mobile infrastructure. These are erased so efficiently that their former presence becomes speculative. Earth also erases quietly. Most erasure does not look dramatic. It looks like nothing happening. A wall slumps, a roof collapses, plants grow, soil builds up. After a while, there is no clear boundary between human alteration and natural terrain. Silence is the signature of erasure. Some things Earth erases selectively based on location. Coastal areas are especially vulnerable. Wave action, salt corrosion, rising sea levels, and sediment movement destroy structures relentlessly. Any civilization that favoured coast would lose much of its physical record quickly once abandoned. Floodplains are another erasing environment. They're fertile and attractive, but they're constantly reshaped by rivers. Settlements are buried, eroded, and reburied. Over time, layers mix. Context disappears. Forests erase through growth. Deserts erase through movement. Ice erases through force. No environment preserves everything. This means Earth does not simply erase the past. It edits it according to environmental bias. Another thing Earth erases early is evidence of coordination. Social systems, governance structures, economic networks, and cultural institutions do not give direct physical traces. Their existence must be inferred indirectly, through patterns in material remains. Once those patterns are disrupted, the systems vanish from the record. A society could be highly organised without building anything monumental. Once it dissolves, nothing obvious remains to indicate that organisation ever existed. Earth erases cooperation more completely than conflict. Warfare leaves clearer marks than peace. Fortifications survive better than marketplaces. Weapons survive better than laws. This skews the record toward violence and hierarchy, making the past appear harsher and simpler than it was. The first things Earth erases are the soft things. The things that made life livable. The things that allowed societies to function smoothly. What remains are often the hard, blunt, and exceptional artifacts, not the everyday reality. This creates a distorted lens through which we view deep time. Earth also erases intention. Once context is lost, objects lose meaning. A carved stone may be interpreted as a tool, a symbol, or a natural formation depending on circumstance. Without supporting evidence, interpretation becomes tentative. This ambiguity grows with age. The older something is, the harder it is to interpret confidently. Earth erodes clarity along with material. It is also important to recognise that erasure is cumulative. Each cycle of occupation, abandonment, and reuse strips away earlier layers. Later societies unknowingly erase earlier ones simply by living on the same land. Over thousands of years, this process repeats many times. Cities are built atop cities. Fields replace settlements. Roads cut through ancient ground. Each iteration overwrites what came before. Even modern archaeology participates in erasure. Excavation destroys context. What is preserved is documented, but the physical arrangement is gone. This is necessary, but it highlights how fragile context really is. Earth does not store backups. When asking what Earth erases first, the answer is not mystery or anomaly. It is normal life. The ordinary structures and tools that supported people day to day, the quieter technologies, the systems that worked well enough not to demand monumentality. Earth erases restraint efficiently. What survives tends to be excess, monumental construction, durable waste, catastrophic destruction. These are the things that resist erasure longest, not because they mattered most, but because they were harder to dismantle. This realization reframes absence. When we do not find evidence of certain kinds of societies in deep time, it does not necessarily mean they did not exist. It means they may have existed in forms Earth is especially good at forgetting. Understanding what Earth erases first helps explain why the deep past looks sparse and uneven. It also explains why certainty about absence is risky. The planet is not hiding secrets deliberately. It is simply doing what it always does, breaking things down, redistributing materials, returning structures to processes. Earth forgets gently but thoroughly. It erases the ordinary first, leaving behind a record dominated by exceptions. And when we read that record, we must remember that what we see is not what mattered most, but what happened to survive long enough to be noticed. Instead of treating civilization as something that humanity reaches and then keeps forever, it may be more accurate to see it as something humanity passes through, a condition that emerges under certain circumstances, persists for a time, and then gives way to something else when those circumstances change. This perspective does not diminish civilization. It places it in context, not as an endpoint, but as a temporary arrangement within a much longer and less stable human story. The idea of civilization as a destination is deeply embedded in modern thinking. From early education onward, history is often presented as a journey with direction. Humans begin in small, scattered groups. They develop tools, they settle, they farm, they build cities, they write, they industrialize. The implicit message is that this sequence represents progress toward a stable, advanced state. Civilization, once achieved, is assumed to be the natural and permanent mode of human existence. But permanence is not something Earth offers freely. When examined across deep time, civilization appears less like a final achievement and more like a phase that comes and goes depending on conditions. It arises when climate stabilizes, resources align, populations reach sufficient density, and disruption remains limited. It struggles or dissolves when those supports weaken. This pattern does not point to failure, it points to contingency. Civilization depends on layers of interdependence. Food systems rely on predictable seasons. Trade relies on safe routes. Governance relies on shared norms and communication. Knowledge relies on continuity. None of these layers are guaranteed over long spans of time. Each one is vulnerable to environmental, biological, and geological forces beyond human control. When enough layers fail simultaneously, civilization does not collapse dramatically. It simplifies. Simplification is often misunderstood as regression or loss of intelligence. In reality, it is a survival response. When conditions no longer support large-scale coordination, societies shed complexity to reduce vulnerability. Smaller groups are easier to feed. Local knowledge is easier to maintain. Mobility becomes an advantage. Redundancy replaces specialization. From within the process, this does not feel like falling backward. It feels like adapting forward into a new set of constraints. This reframing challenges the notion that civilization is the natural culmination of intelligence. Intelligence existed long before civilization and will likely persist long after particular forms of civilization end. What changes is how that intelligence is expressed. Civilization requires stability to accumulate. It requires enough time without major disruption for systems to build on themselves. but stability is not the default state of Earth. Over the last several 100,000 years, the planet has experienced repeated climate swings, sea level changes, glaciations, and ecological reorganizations. Long, uninterrupted periods of calm are rare. When viewed against this backdrop, the recent rise of global civilization appears less inevitable and more opportunistic. It emerged during an unusually stable interglacial period. Sea levels stabilized, agriculture became reliable, populations expanded, surplus allowed specialization, writing allowed memory to extend beyond individuals. These conditions aligned and civilization flourished. There is no guarantee they will remain aligned indefinitely. Looking backward, it becomes plausible that similar alignments occurred before. Not identical, but sufficient to support organized societies at various scales. Each time, civilization would have functioned as a phase. It would have shaped human behavior, knowledge, and landscape. And each time when conditions shifted, it would have thinned, fragmented, or dissolved. What followed would not be emptiness. It would be a different phase of human existence. This perspective also helps explain why civilization does not spread uniformly or permanently. Even within the last few thousand years, highly organized societies have coexisted with groups that live differently. Urban centers existed alongside mobile communities. Complex states rose and fell while other ways of life persisted uninterrupted. Civilization did not replace all other modes of living. It layered itself on top of them, temporarily dominant in some regions, absent in others. The idea of civilization as a destination encourages a binary view, civilized versus uncivilized, advanced versus primitive. This framing obscures the diversity of human adaptation. It treats complexity as a moral achievement rather than a contextual response. In reality, civilization is expensive. It consumes resources. It concentrates risk. It creates dependencies. It amplifies the consequences of disruption. These costs are acceptable only when the environment allows them to be managed. When the environment changes too quickly or too severely, the costs outweigh the benefits. Seen this way, civilization is not a reward for intelligence. It is a strategy that works under specific conditions. There is another reason this reframing matters. It changes how we interpret disappearance. If civilization is assumed to be a destination, then its absence in deep time feels like a mystery requiring explanation. Why did humans wait so long? Why did progress stall? Why do we see gaps? If civilization is a phase, then absence becomes normal. Phases come and go. This also reframes collapse. Collapse is often portrayed as failure, moral decay, or incompetence. While human decisions do matter, collapse is frequently the result of external pressures overwhelming existing systems. Droughts, floods, cooling periods, disease, or resource depletion can destabilize even well-managed societies. When collapse occurs, it does not erase humanity. It transitions humanity into another phase. Archaeology tends to privilege phases that leave durable material remains. Civilizations that built in stone, fired clay, or metal appear prominently. Phases that relied on organic materials, mobility, or subtle environmental management fade quickly from view. This skews our sense of continuity. We see civilization appear once and persist because we are living in one of its visible phases. We do not see how often it may have flickered elsewhere and elsewhen. Another important implication is how knowledge behaves across phases. Knowledge does not vanish all at once. It fragments. Pieces survive in different forms. Practical skills may persist even as theoretical understanding fades. Techniques may be preserved without explanation. Stories may encode patterns without context. Over time, knowledge reassembles differently. When conditions allow, complexity can re-emerge, not by continuing from where it left off, but by recombining surviving elements into new systems. This recombination does not require a direct line of descent. It requires enough overlap between memory, environment, and opportunity. Civilization, then, is not cumulative in a straight line. It is iterative. Each iteration may look different. It may emphasize different technologies, materials, or social structures. Some iterations may be louder and leave more debris, others may be quieter and leave almost none. From a deep time perspective, all are temporary. This challenges modern assumptions about permanence. We often think in terms of safeguarding civilization, preserving it, making it sustainable indefinitely. These are reasonable goals within a human timescale, but Earth does not operate on human timescales. Sustainability may mean persistence across centuries. Earth measures in tens of thousands of years. From that perspective, even the most stable civilization is brief. Seeing civilization as a phase also helps explain why humans are capable of moving between modes of existence. People adapt quickly when systems fail, skills shift, priorities reorder. What mattered before may no longer matter. New forms of cooperation emerge. This adaptability is not a flaw, it is a strength. It also suggests that intelligence is not tied to a single expression. Humans do not become less intelligent when civilization thins. They become intelligent in different ways. Tracking animals, reading weather, managing risk locally, maintaining social cohesion in small groups. These are not lesser skills. They are different skills optimized for different conditions. When conditions stabilize again, intelligence can express itself through accumulation once more. This cyclical view aligns with what we know about human resilience. It also aligns with what we observe in the archaeological record. Bursts of complexity followed by simplification, followed by new complexity in different forms. What it undermines is the belief that civilization is the natural end state of humanity. Instead, civilization appears to be one strategy among many, effective under certain conditions, vulnerable under others. This does not mean civilization is doomed or meaningless. It means it should not be mistaken for permanence. If civilization has happened before, it likely did not announce itself as a grand first. It would have felt ordinary to those living within it. People would have assumed their world was normal, just as we do. They would have planned for the future, built systems and passed on knowledge, unaware of how fragile their phase truly was. When conditions shifted, their civilization would not have left a clean endpoint. It would have thinned, simplified, and blended back into other modes of living. To future observers, it might not look like civilization at all. It might look like a gap. This perspective also shifts how we view our own moment. If civilization is a phase, then the question is not whether it will last forever, but how it will change as conditions evolve. Adaptation may not mean preserving everything. It may mean letting some things go. Earth has hosted many phases of life, many arrangements of ecosystems, many dominant species. None were permanent. Humans are unusual not because we build civilizations, but because we are aware of impermanence and still try to plan beyond it. That awareness does not grant immunity. Understanding civilization as a phase encourages humility. It suggests that being first or last is less important than being responsive. It invites curiosity rather than certainty. Civilization is not a destination stamped into human destiny. It is a temporary configuration, assembled when conditions allow and dismantled when they do not. Earth has no obligation to preserve it, and history has no obligation to repeat it in the same form. What remains constant is not civilization itself, but humanity's ability to adapt as one phase gives way to another. Across the span of human existence, the question is not whether there was time for civilization to appear before the one we know, but how often the conditions for it may have aligned. Once the scale of time is widened beyond recorded history, the problem shifts from imagination to arithmetic. Humans have been anatomically modern for roughly 200,000 years. Written history covers only a few thousand of those. Everything else lies outside memory that can be read directly. That leaves an immense expanse of time where human intelligence existed without written continuity. Within that expanse, Earth did not stand still. climate fluctuated, ice advanced and retreated, sea levels rose and fell. Ecosystems reorganized repeatedly. These changes did not occur once. They occurred over and over again, creating windows of relative stability separated by periods of disruption. Each stable window is a candidate. To understand how many times civilization could have happened, it helps to strip the idea of civilization down to its minimum requirements. It does not require skyscrapers, electricity, or global networks. It requires sustained cooperation beyond small kin groups. It requires shared systems of food production or resource management. It requires enough predictability for knowledge to accumulate across generations. And it requires enough time without catastrophic interruption for those systems to mature. None of these requirements demand tens of thousands of years. History shows that complex societies can emerge in surprisingly short periods when conditions allow. In some regions, cities formed within a few thousand years of the adoption of agriculture. Trade networks expanded rapidly once surplus existed. Social hierarchies, governance structures, and cultural institutions followed. If that process can happen once, it can happen again. Looking back across the last 200,000 years, the planet experienced multiple interglacial periods. These warmer intervals often lasted 10,000 years or more. During those times, ice retreated, sea levels stabilized, and ecosystems became more predictable. Human populations expanded into newly available land. Resources diversified. Each interglacial provided not just space but opportunity. Even within glacial periods, there were milder phases. Regional climates varied. Some areas remained stable enough to support dense populations, while others were inhospitable. Civilization, if it arose, would not need to be global. It could be regional, localized, and still meet meaningful definitions of complexity. The question then becomes, how many such opportunities existed? Over the last 200,000 years, there have been multiple interglacial cycles. Depending on how they are counted, there may have been 5 to 10 significant warm periods, long enough to support sustained human development. Within each, there were likely shorter stable subperiods as well. Even if only a fraction of these windows were suitable for complex societies, the number of opportunities exceeds 1 by a wide margin. Now consider human migration patterns. Humans did not occupy the planet evenly or continuously. Populations expanded, contracted, and shifted repeatedly. When conditions worsened in one region, people moved to another. This movement redistributed knowledge, practices, and social structures. A society could arise in one region, decline, and then re-emerge elsewhere in a different form, carrying fragments of earlier experience without direct continuity. From the perspective of deep time, these would appear as separate events, even if there was some cultural inheritance between them. Another factor is population density. Civilization requires enough people in close enough proximity to support specialization. Human population density has not been constant. It has risen and fallen dramatically in response to climate, disease, and resource availability. There were periods when human populations were larger and more concentrated than at other times. Those periods would have been especially conducive to complex organization. Population bottlenecks reset this process. After a bottleneck, density drops, knowledge fragments, complexity thins. But as populations recover, complexity can re-emerge. Not necessarily in the same way, but in ways shaped by new conditions. This suggests a repeating pattern rather than a single event. One might argue that even if civilization arose multiple times, the early ones would have been limited in scale or sophistication. That may be true, but sophistication is relative. A society does not need to resemble modern civilization to qualify as complex. It needs only to organize itself beyond immediate survival. There is also the issue of duration. Civilization does not need to last tens of thousands of years to matter. A few thousand years is enough to leave a cultural imprint, alter landscapes, and reshape human behavior. But a few thousand years is also short enough to be erased almost completely by geological and environmental processes. If a civilization lasted 3,000 years during an interglacial period and then was erased by advancing ice, rising seas, or prolonged drought, its physical traces could be nearly undetectable today. Repeat that process multiple times, and the cumulative record still looks sparse. Another way to approach the question is to consider how often the conditions for agriculture existed. Agriculture is not the only path to civilization, but it is a common one. Agriculture depends on stable climate, predictable seasons, and suitable soils. Paleoclimate evidence suggests that such conditions existed intermittently across different regions long before the Neolithic period recognized in textbooks. These conditions were not globally synchronized. They appeared regionally and disappeared regionally. This means that agriculture or agriculture-like practices could have arisen independently in different places at different times, then been abandoned when conditions changed. Each agricultural phase increases the likelihood of complex social organization. The number of potential agricultural windows across 200,000 years is large. Another constraint often overlooked is cultural choice. Not every society will pursue complexity even when conditions allow it. Some may prioritize mobility, equality, or ecological balance over accumulation and hierarchy. Civilization may be possible but not chosen, or chosen only partially. This means the number of times civilization could have happened is not the same as the number of times it did happen. But it also means that the absence of visible civilization does not imply lack of opportunity. Opportunity and outcome are not the same. It is also important to consider that civilizations do not appear fully formed. They emerge gradually, often indistinguishable from non-civilizational societies until certain thresholds are crossed. From an archaeological perspective, the early stages of civilization are difficult to identify. They look like intensified versions of existing practices rather than a sharp break. If those early stages were cut short repeatedly by disruption, they would leave minimal trace. This suggests that the number of partial civilizations, aborted civilizations, or proto-civilizations could be much higher than the number of fully developed ones. How many times could humanity have approached complexity only to be pushed back before it became archaeologically obvious? The answer is likely many. Another angle involves energy use. Civilization depends on surplus energy. That energy can come from food, animals, water, wind, or other sources. Fossil fuels are a recent addition, not requirement. Earlier civilizations would have relied on renewable flows. Renewable energy limits scale, but not organization. It favors regional complexity rather than global dominance. Such civilizations could function well within their constraints and then disappear quietly when energy flows were disrupted. From a modern standpoint, these civilizations might appear small or insignificant. From within, they could have been rich and complex. The question of how many times also depends on how strictly one defines repetition. If civilization must look similar each time to count, then the number is low. If civilization is allowed to take different forms adapted to different conditions, then the number increases. There is no reason to expect repetition to produce identical outcomes. Evolution does not repeat exact forms. It explores possibilities within constraints. Human societies likely did the same. If civilization is a phase rather than a destination, then it is reasonable to expect it to recur whenever conditions allow, just as forests return after fires and grasslands return after floods. The details differ. The pattern persists. This perspective does not claim that civilization has definitely happened many times. It claims that the temporal and environmental space for it to have happened many times exists. Certainty in either direction exceeds the evidence. What can be said with confidence is that the long human story is mostly invisible to us. The fraction we can see is shaped by preservation bias, not by importance. The deep past is not empty. It is undersampled. If civilization arose once under a specific set of conditions, then those conditions are not unique in Earth's recent history. Similar alignments likely occurred before and may occur again. This reframes the question away from proof and toward plausibility. How many times could this have happened? More than once? More than a handful? Potentially many times, depending on how narrowly or broadly civilization is defined. What remains unknown is not whether repetition was possible, but how much of it Earth chose to forget. Each cycle of stability followed by disruption would thin the record further. Each erasure would remove context. Over time, the accumulation of forgotten attempts would leave behind a record that looks deceptively singular. We see one rise because it is the one we are inside. This realization should not inspire certainty or speculation, but perspective. Human history is not short. It is vast. Civilization, as we experience it, occupies a narrow slice within that vastness. Whether it has happened once or many times, the conditions that allow it are temporary. The processes that erase it are persistent. Some questions remain open not because they are forbidden, but because the planet has already done its editing. And once that editing is complete, even arithmetic gives way to humility. Certainty feels like a reasonable expectation when questions are framed carefully and enough effort is applied. In many areas of science, uncertainty shrinks as data accumulates, methods improve, and perspectives sharpen. It is natural then to assume that with sufficient time, technology, and curiosity, even the deepest questions about human history should eventually yield clear answers. Yet there are limits to what can be recovered, and the question of whether civilization has happened before may sit beyond one of those limits permanently. The reason is not lack of intelligence, motivation, or rigor. It is the nature of the system we are trying to read. Earth is not a static archive. It is an active process. Everything that preserves information also transforms it, and everything that transforms it selectively erases. By the time a question is asked tens or hundreds of thousands of years later, the material needed to answer it cleanly may no longer exist in any coherent form. This is the first barrier to certainty. The record itself is incomplete in ways that cannot be repaired. Unlike historical questions that deal with recent centuries, deep time questions depend on physical traces that have survived immense pressure from erosion, chemistry, biology, and tectonics. These processes do not merely thin the record, they reshape it unevenly. Some places preserve more, others preserve almost nothing. Entire regions are recycled into the mantle or buried under kilometers of sediment. Once material is gone, it cannot be reconstructed. No future technology can recover information that no longer has a physical carrier. This means that the question is constrained not by what we have not yet found, but by what no longer exists to be found. Another limitation comes from scale. Human civilization, even at its most expansive, occupies a tiny fraction of Earth's surface and an even smaller fraction of Earth's time. Geological processes operate on vastly larger scales. They do not just outpace human activity, they overwhelm it. When asking whether civilization has happened before, we are effectively asking whether subtle, localized, short-lived patterns can be detected after being processed by a system designed to erase such patterns. That is not a fair contest. There is also the issue of ambiguity. Even when evidence does survive, it rarely speaks clearly. A structure may be natural or artificial. A chemical anomaly may be biological or industrial. A pattern in sediments may be climatic or anthropogenic. Interpretation depends on context, comparison, and assumptions. As time deepens, context evaporates faster than material. This leads to a fundamental asymmetry. Evidence against earlier civilization must be extraordinarily strong to rule it out conclusively, because absence can always be explained by erasure. Evidence for earlier civilization must also be extraordinarily strong, because ambiguous traces can almost always be explained by natural processes. The result is a narrowing zone where certainty becomes unreachable. Another barrier is definitional. Civilization is not a single, universally agreed upon concept. Definitions shift depending on disciplinary focus. Archaeologists may emphasize urbanization and writing. Anthropologists may emphasize social complexity and sustained cooperation. Ecologists may emphasize landscape modification. Each definition changes what counts as evidence. If earlier civilizations did not match later ones in form, scale, or material expression, they may fall outside commonly used definitions entirely. In that case, even clear evidence of complex organization could be misclassified or overlooked. Certainty requires agreement on what would count as proof. That agreement does not exist. There is also the problem of survivorship bias in interpretation. The civilizations we know best are the ones that left durable remains in favourable conditions. Stone-built societies in arid regions dominate historical narratives because their material culture survived. This shapes expectations unconsciously. When we look for civilization, we look for things that resemble what we already know. When we do not find them, we assume absence rather than difference. The deeper the past, the more this bias matters. Technological progress does not eliminate this problem. It can reveal more, but it cannot reveal everything. LIDAR can see through forests, but it cannot see through tectonic recycling. Chemical analysis can detect anomalies, but it cannot reconstruct vanished systems. Artificial intelligence can find patterns, but it cannot infer intent from noise with certainty. Every method extends vision in one direction while leaving others untouched. Another reason certainty may be impossible lies in repetition itself. If civilization arose, collapsed, and arose again multiple times, the overlapping traces of these events would blur together. Later cycles would disturb earlier ones. Materials would be reused. Landscapes would be reshaped repeatedly. What remains would not represent a clean sequence, but a composite. Untangling that composite into discrete events separated by tens of thousands of years may not be feasible. It is like trying to reconstruct individual brushstrokes after a painting has been painted over dozens of times. Time also introduces a statistical problem. The further back we look, the smaller the probability that any given trace survives. At some point, the expected number of surviving indicators drops below 1. That does not mean nothing happened. It means the odds of detecting it approach 0. This is a hard limit, not a temporary one. There is also a cultural limitation. Humans are meaning-making creatures. We prefer stories with clear beginnings, developments, and conclusions. We prefer answers that close questions rather than leave them open. This preference shapes interpretation. In ambiguous cases, there is pressure to settle on the simplest explanation that fits existing frameworks. This is not dishonesty. It is cognitive efficiency. But it means that marginal possibilities, even plausible ones, are often sidelined. Over time, sidelined possibilities fade from discourse, not because they were disproven, but because they were inconvenient. The question of earlier civilizations sits uncomfortably at the edge of mainstream frameworks. It is neither clearly supported nor clearly refuted. As a result, it tends to oscillate between dismissal and speculation, rather than sustained, cautious consideration. This oscillation itself limits progress towards certainty. Another important factor is that civilization does not announce itself at its beginning. It emerges gradually. The early stages of complexity are difficult to distinguish from intensified versions of non-civilizational life. From a material standpoint, the difference between a large, well-organized non-urban society and an early civilization can be subtle. If such early stages were cut short repeatedly, they might never cross the threshold where we would recognize them clearly. In that case, the question of whether civilization happened before becomes entangled with the question of how close humanity came to it multiple times. That is not a binary question, it is a spectrum. Certainty struggles with spectra. There is also the matter of geographical unevenness. Earth does not preserve all regions equally. Some areas are geological graveyards, others are geological blenders. If earlier civilizations were concentrated in regions that are now submerged, eroded, or tectonically active, their chances of detection are minimal. The distribution of known ancient civilizations may say more about preservation conditions than about where civilization actually arose. This unevenness cannot be corrected retroactively. Another obstacle is that civilization may not leave a single diagnostic signature. Modern civilization leaves multiple overlapping ones because it is unusually material intensive and global. Earlier civilizations, if they existed, may have left narrower signatures, each individually ambiguous. Without a unique marker, such as a globally distributed, unmistakably artificial material layer, certainty remains elusive. Even modern civilization may not leave such a marker over deep time. This leads to a humbling realization. Some questions are answerable only within certain temporal windows. Once those windows close, the questions persist, but the means of answering them do not. The question of earlier civilizations may be one of those. This does not make the question meaningless. It makes it philosophically important. It forces us to confront the limits of historical knowledge and the difference between what likely happened and what can be proven. Science is often described as a method for eliminating uncertainty. It is also a method for defining uncertainty precisely. Knowing that a question cannot be answered definitively is itself a form of knowledge. There is value in recognizing that the past is not fully recoverable. This recognition also guards against overconfidence. Both the confident assertion that civilization happened many times and the confident assertion that it happened only once exceed what the evidence can support conclusively. The responsible position lies between them. That position is uncomfortable because it does not resolve curiosity. It leaves the question open. Yet openness is appropriate when dealing with deep time. Another reason certainty may remain out of reach is that new evidence does not always clarify. Sometimes it complicates. Each new discovery adds detail but also raises new questions. Each anomaly forces reinterpretation of existing frameworks. The more we learn, the clearer the gaps become. This pattern is common in science. Knowledge expands, but so does awareness of what is unknown. In deep history, the unknown may always outpace the known. It is also worth noting that certainty about being the first is not necessary for understanding our place in the world. Whether civilization has happened once or many times does not change the fragility of our current moment. It does not alter the fact that civilization depends on conditions that are not guaranteed. In that sense, the practical lesson is the same regardless of the answer. The inability to know for certain is not a failure of inquiry. It is a feature of the system being studied. Earth does not preserve intentions. It preserves outcomes selectively. Human history beyond a certain depth becomes probabilistic rather than factual. This shifts the role of questions like this one. They become tools for perspective rather than puzzles to be solved conclusively. Why might we never know for certain? Because the planet has already decided what survives. Because definitions blur with time. Because evidence decays faster than curiosity. Because ambiguity increases as context fades. Because repetition erases distinction. Because certainty requires conditions that no longer exist. Accepting this does not end the inquiry. It reframes it. If the idea is allowed to settle gently without rushing toward conclusions, a different kind of meaning begins to surface. Not meaning in the sense of proof or refutation, but meaning in how the story of humanity changes if the assumption of being first quietly dissolves. The question stops being about ancient ruins or lost technologies and becomes something more personal, more philosophical, and more unsettling in a subtle way. What it means if we're not the first is not that our civilization is illegitimate, borrowed, or diminished. It means that civilization itself is not a miracle that happens once, but a condition that emerges when circumstances allow it. It means that intelligence organizing itself into complex systems may be less exceptional than we imagine, and far more fragile. The most immediate shift is how we see progress. Modern culture is steeped in the idea that progress accumulates, that knowledge stacks upward, that each generation stands on the shoulders of the last, climbing steadily towards something more advanced and more permanent. This story feels reassuring because it suggests direction. It suggests that history is going somewhere, and that somewhere includes us by default. If we are not the first, that story becomes harder to maintain. Progress begins to look conditional rather than guaranteed. Accumulation becomes reversible. Advancement becomes something that can be undone not by stupidity or moral failure, but by circumstance. The past stops being a simple runway leading to the present and starts looking like a field marked by multiple paths, many of which ended without warning. This reframing does not make human achievement smaller, it makes it more precarious. Another consequence is how we understand intelligence itself. We often associate intelligence with visible output, monumental architecture, complex machines, written systems, global reach. If earlier civilizations existed but did not leave such outputs behind, or left outputs that Earth erased efficiently, then intelligence becomes less about what survives and more about what adapts. Intelligence stops being measured by footprint and starts being measured by resilience. This has an uncomfortable implication. A society can be intelligent, creative, and sophisticated, and still leave almost nothing behind. From the perspective of deep time, such a society might appear indistinguishable from one that never achieved complexity at all. If we are not the first, then archaeology is not a ranking of intelligence, it is a ranking of durability. That alone should change how confidently we speak about the past. It also reshapes how we interpret absence. Right now, absence often feels like closure. No evidence, therefore no event. No ruins, therefore no civilization. If repetition is possible, absence becomes ambiguous. It may still mean non-existence, but it may also mean erasure, quietness, or incompatibility with preservation. This does not open the door to unlimited speculation. It closes the door on unwarranted certainty. Another meaning emerges around humility. Being first carries an unspoken sense of uniqueness. It suggests that something about our species, our era, or our choices set us apart from everything that came before. It encourages narratives of destiny, of arrival, of culmination. If we are not the first, then we are not the culmination either. That does not imply insignificance. It implies participation in a larger pattern, a pattern where intelligence rises, organizes, experiments, and sometimes loses continuity. A pattern shaped as much by Earth as by human choice. Humility in this sense is not self-doubt, it is perspective. There is also a shift in how we view collapse. Collapse is often treated as an aberration, a deviation from the proper course of history. It is framed as something to be avoided at all costs, a failure of management, ethics, or foresight. While human decisions absolutely matter, the possibility that civilization has collapsed before reframes collapse as part of a broader cycle rather than an unthinkable endpoint. If earlier civilizations existed and ended, collapse stops being unique. It becomes familiar. This does not make it acceptable or desirable, it makes it comprehensible. Another implication is how we think about sustainability. Much of modern sustainability discourse is built around the idea of making civilization permanent, maintaining growth indefinitely, stabilizing systems so they never fail, preserving complexity across all foreseeable futures. If civilization is a phase rather than a destination, sustainability may need to be rethought, not as permanence, but as graceful transformation, not as preventing all change, but as managing transitions in ways that preserve what matters most. If earlier civilizations existed and disappeared, they may offer an implicit lesson. Not that collapse is inevitable, but that rigidity is dangerous. This reframing also changes how we see innovation. Innovation is often treated as a one-way process. Once something is invented, it becomes part of the permanent toolkit of humanity. In reality, innovation is reversible. Techniques are lost, methods disappear. Entire categories of knowledge can vanish when the conditions that support them vanish. If we are not the first, then innovation is not a ladder. It is a landscape. This landscape has peaks and valleys. Some peaks are climbed multiple times. Others are reached once and forgotten. From a distance, the terrain looks uneven rather than directional. Another layer of meaning emerges around memory. Modern civilization is deeply invested in preserving memory. Archives, databases, records, redundancy. We assume that because we are recording everything, we are immune to forgetting. But if earlier civilizations recorded their knowledge in ways that did not survive, or in ways that required continuity to remain meaningful, then memory itself becomes fragile. If we are not the first, then memory is not cumulative by default. It must be actively protected, interpreted, and renewed. Even now, vast amounts of knowledge exist only in formats that depend on infrastructure. Without power, software, and compatibility, much of what we know becomes inaccessible almost instantly. The lesson is not that recording is futile, but that recording is not enough. Continuity matters more than storage. Another implication touches identity. Many modern narratives place humanity on a pedestal relative to the past. We are portrayed as wiser, more informed, more capable than those who came before. This belief underpins confidence in our ability to manage the planet, engineer solutions, and avoid catastrophic mistakes. If we are not the first, that confidence deserves examination. Earlier civilizations, if they existed, may have believed similar things. They may have felt advanced relative to their ancestors. They may have assumed their systems were stable. They may have planned for futures that never arrived. This does not mean we are doomed to repeat the same mistakes. It means that awareness of impermanence should temper certainty. Another meaning arises around responsibility. If civilization is not unique, then stewardship becomes more important than legacy. Building monuments to be remembered becomes less relevant than maintaining conditions that allow future societies, in whatever form, to exist at all. If earlier civilizations existed and vanished, the Earth did not grieve them. It continued. Life continued. New arrangements emerged. What matters then is not being remembered forever, but acting responsibly while present. There is also a shift in how we view technological ambition. Modern civilization often equates advancement with scale. Bigger systems, faster networks, greater reach. But if quiet civilizations could exist and vanish without leaving scars, then technological ambition does not have to mean expansion. Restraint becomes a valid expression of intelligence. If we are not the first, then the loudness of our technological footprint is a choice, not an inevitability. And choices have consequences. Another implication concerns fear. Some people react to the idea of earlier civilizations with anxiety. It feels destabilizing, as if it undermines the certainty of our place in history. But the fear often comes from misunderstanding what "not first" implies. It does not imply that nothing we do matters. It implies that what matters is context-dependent. A song is not meaningless because it ends. A life is not meaningless because it is finite. A civilization is not meaningless because it is temporary. Meaning does not require permanence. This perspective can actually be grounding. It removes the pressure to be ultimate, to be final, to be the last word. It allows civilization to be valued for what it provides in the present rather than what it leaves behind in the distant future. Another subtle meaning involves curiosity itself. If we are not the first, then the past is richer and strange than we assume, not in a sensational way, but in a human way. It means there were people before us who lived through complexity, stability, uncertainty, and loss in ways we can barely imagine. It invites empathy across time. This empathy does not require proof of specific civilizations. It requires recognition that human experience has likely been more varied than our surviving records suggest. There is also an ethical implication. If civilization has happened before and ended, then future civilizations may arise after ours, assuming conditions allow. The way we treat the planet, the climate, and the biosphere affects not just ourselves, but any future societies that may inherit the world. If we're not the first, then we are part of a chain, not the conclusion. That chain carries responsibility forward. Another meaning lies in how we approach uncertainty. Modern discourse often treats uncertainty as a problem to be eliminated, but some uncertainties are structural. They arise from the nature of the system being studied. Deep human history is one of those systems. If we are not the first, certainty may never be available. That does not weaken inquiry. It strengthens philosophical humility. Living with unanswered questions is part of maturity, not failure. This perspective also reshapes wonder. The idea that civilization might have arisen before us does not cheapen our story. It deepens it. It situates humanity within a broader rhythm of emergence and disappearance that mirrors patterns seen throughout nature. Forests return after fires. Species radiate and go extinct. Rivers shift and reform. Civilization may follow similar rhythms. Seeing ourselves as part of that rhythm can be unsettling, but it can also be calming. It reminds us that change is not betrayal, it is participation. Another implication is how we think about success. Modern civilization often defines success in terms of growth, accumulation, and permanence. If earlier civilizations existed and vanished, success may need to be defined differently. Success might be measured by how well a society navigates change, rather than how long it resists it. This does not mean abandoning ambition. It means aligning ambition with reality. There is also a personal meaning. Individuals often internalize civilizational narratives. We measure our lives against progress stories, careers, achievements, legacy. If civilization itself is temporary, individual lives can be freed from the burden of cosmic significance. Meaning becomes local, relational, and present-focused. This does not diminish aspiration. It clarifies it. If we are not the first, then the universe is not watching us to see how the story ends. It is watching us, if anything, to see how we live within our moment. The question then becomes less about proving whether civilization has happened before, and more about what kind of civilization we are choosing to be now. That shift in focus may be the most important meaning of all. Because whether or not we are the first, we are here. We are aware. We are capable of reflection. And we are living within a narrow window of stability that has allowed complexity to flourish. That window will not remain open forever. Understanding that does not require certainty about the past. It requires honesty about the present. Here we are then, not at an ending, but at a pause that feels worth noticing. After moving slowly through deep time, through erasure, repetition, uncertainty, and possibility, attention naturally drifts back to the present moment, not as a conclusion to everything that came before, but as a place to stand briefly and look around with slightly different eyes. Where we are now is not just a point on a timeline, it is a condition. Modern civilization exists within a narrow window of stability that did not have to exist and will not remain open indefinitely. This is not a prediction or a warning. It is simply a description of how Earth works. Climate stabilizes for a time, then shifts. Sea levels pause, then move. Ecosystems settle, then reorganize. Human systems expand into that calm, then are tested when it ends. Right now, we're inside one of those calm intervals. From within it, the world feels solid, cities feel permanent, infrastructure feels foundational, knowledge feels cumulative, memory feels secure. The idea that civilization could thin or fragment feels distant, theoretical, or exaggerated. That sense of solidity is understandable. It is also temporary. What makes this moment unusual is not that civilization exists, but that we are aware of its fragility while still living inside it. Many societies likely lived through similar phases without understanding how contingent their stability was. They planned futures assuming continuity because continuity was all they had known. We have more information than that. We know the planet's history is restless. We know climates shift. We know collapses happen. We know memory fails. And yet, daily life continues as if stability were the default. That tension defines where we are now. Another feature of the present moment is scale. Human activity now operates at a planetary level. Climate systems are influenced by industrial output. Ecosystems are altered globally. Materials created by human processes circulate through oceans, soils, and atmospheres. This scale is unprecedented in known history, but not necessarily unprecedented in principle. What is different is speed. Change is happening faster than many systems can adapt. Social, political, and technological systems are tightly coupled, which makes them efficient, but also brittle. Disruptions propagate quickly. Local failures cascade globally. Complexity amplifies both capability and risk. This does not mean collapse is inevitable. It means resilience matters more than confidence. If civilization is a phase, then the present phase is marked by extreme interconnectedness. That interconnectedness allows for rapid innovation and coordination. It also reduces the margin for error. When systems are interdependent, failures rarely stay isolated. This is not a moral judgment. It is a structural reality. Another aspect of where we are now is how we relate to time. Modern civilization is future-oriented. Planning, forecasting, optimization, and growth are central values. We invest heavily in projections. We expect continuity because planning depends on it. At the same time, we're increasingly aware that long-term projections are unreliable in a changing system. Climate models, economic forecasts, and geopolitical predictions all carry growing uncertainty. The future feels both urgent and unclear. This creates a psychological strain. We are asked to plan as if stability will continue, while knowing it may not. Earlier societies likely felt similar tension in different forms. They faced droughts, floods, cooling periods, or social upheaval without understanding the broader patterns behind them. They adapted locally. Some adaptations worked, some did not. What distinguishes the present is not immunity to disruption, but awareness of it. That awareness raises questions about responsibility. If civilization is not guaranteed to persist, then choices made now shape not only immediate outcomes, but the conditions under which future societies, if any, will emerge. The planet does not care whether those societies resemble ours. It only responds to physical processes. What we alter now becomes part of the environment others inherit. This reframes legacy. Legacy is often imagined as being remembered. Buildings, monuments, records, achievements. But if Earth erases most things eventually, then legacy is less about memory and more about conditions. Soil health, biodiversity, climate stability, resource distribution. The most durable legacy may not be what we build, but what we leave intact. Another quiet feature of the present moment is inequality. Not all people experience civilization in the same way. Stability is unevenly distributed. Some live with abundance and infrastructure. Others live with precarity and constant disruption. For many, the idea of civilization as a stable phase already feels abstract. This unevenness matters because it mirrors how civilizations thin. Collapse is rarely uniform. It affects some regions earlier and more severely than others. Adaptation happens unevenly. Knowledge and resources concentrate and disperse. Understanding this helps avoid romanticizing either civilization or collapse. Both are lived experiences shaped by circumstance. Another element worth noticing is how strongly modern civilization values permanence. Preservation is a central concern. Data backups, archives, museums, cultural heritage protection. There is a deep desire to hold on to what exists to prevent loss. That desire is understandable. It is also revealing. It suggests an awareness, even if unspoken, that loss is possible. Earlier societies preserved what they could with the tools they had. Oral traditions, rituals, monumental construction. We preserve digitally, chemically, redundantly. But preservation always depends on continuity. When continuity breaks, preservation becomes meaningless. A hard drive without power is no archive. This raises a subtle point. If earlier civilizations existed and vanished, it was not because they failed to care about memory. It was because the conditions required to sustain memory did not hold. Memory is not a property of storage, it is a property of systems. Where we are now is within systems that feel robust, but whose long-term resilience is untested at planetary scale. Another quiet aspect of the present is acceleration. Change happens quickly enough that adaptation struggles to keep pace. Cultural norms, institutions, and governance structures evolve more slowly than technology. This mismatch creates friction. It also creates uncertainty about which systems matter most to preserve. In periods of rapid change, societies often cling to familiar frameworks, even as conditions render them less effective. This is not stubbornness, it is human inertia. Earlier civilizations likely faced similar moments when existing strategies no longer matched reality. Some adapted, some did not. The record shows outcomes, not intentions. The present moment is not unique in facing this challenge. It is unique in being aware of it globally. Another reflection arises around humility. If civilization has happened before, or even if it has not, the idea that our current arrangement is the final or optimal one becomes difficult to sustain. There may be other ways of organizing human life that are less visible, less extractive, and more resilient. This does not mean abandoning everything familiar. It means remaining open to change that does not fit existing narratives of progress. Civilization, viewed as a phase, invites flexibility rather than attachment. There is also a personal dimension. Individuals often derive meaning from being part of something enduring. Nations, cultures, institutions. The possibility that these are temporary can feel destabilizing, but meaning does not require permanence. It requires engagement. A conversation does not need to last forever to matter. A life does not need to be infinite to be meaningful. A civilization does not need to be eternal to be valuable. Recognizing temporariness can sharpen attention. It can shift focus from accumulation to care, from domination to stewardship, from legacy to responsibility. Another aspect of where we are now is choice. Unlike earlier societies, we possess detailed knowledge of planetary systems and the consequences of certain actions. This knowledge does not guarantee correct decisions, but it introduces moral weight. Ignorance is no longer a full explanation. This does not mean blame. It means awareness changes the nature of responsibility. If earlier civilizations existed and fell without understanding the forces they were up against, our situation is different. We understand more, even if we cannot control everything. That understanding does not make us immune, it makes us accountable. Another quiet realization is that civilization is not synonymous with humanity. Humanity existed before civilization, and will likely exist after particular forms of civilization change or end. The continuity of the species does not depend on maintaining current systems unchanged. This perspective can reduce existential panic. Change does not equal extinction. Transformation is not annihilation. The challenge is navigating transformation without unnecessary suffering. The idea that civilization may have happened before is not meant to undermine the present. It is meant to place it within a broader pattern, where emergence and disappearance are normal. This can foster resilience rather than despair. If others navigated similar phases without our knowledge or tools, then adaptability is deeply rooted in human behavior. Another reflection concerns scale of concern. Modern civilization often thinks globally, but action happens locally. Communities adapt first. Knowledge spreads unevenly. Resilience emerges from networks, not from centralized plans alone. Earlier societies survived by relying on local knowledge and cooperation. That lesson remains relevant regardless of scale. Where we are now is at an intersection between awareness and uncertainty, between capability and vulnerability, between continuity and change. This is not a crossroads with a single correct path. It is a condition that requires ongoing adjustment. One more quiet point deserves attention. Curiosity about the deep past is not escapism. It is a way of understanding limits. By recognizing how much has been erased, how often systems have reset, and how fragile memory is, we gain perspective on what matters now. The question of whether civilization has happened before ultimately redirects attention to how we live within the one we have, not to prove uniqueness, not to chase mystery, but to understand impermanence. If we are not the first, then we are part of a sequence. If we are the first, then we are still temporary. In either case, the conclusion is the same. What matters is not being first or last. It is being aware. Aware that stability is borrowed. Aware that memory fades. Aware that systems need care. Aware that Earth will continue regardless of how any single phase unfolds. This awareness does not demand pessimism. It invites attentiveness. The present moment is quiet in a way that is easy to miss. Not quiet because nothing is happening, but quiet because this is how stability feels from the inside. It feels ordinary. It feels like background. It feels permanent. History suggests otherwise. Holding that tension gently without panic or denial may be one of the most important things we can do. So this is not an ending. It is a settling. A pause where the mind can rest with the idea that civilization is neither a miracle nor a mistake, but a phase shaped by conditions that deserve respect. A phase that carries responsibilities precisely because it is not guaranteed. Where we are now is within that phase, awake enough to question it and present enough to care. And for a moment, that is enough.